Check, check.
You're checking in good. Thank you, Lee. All right. Speaking of Lee, it must be Tuesday night, and it's Keshe Plasma Reactor Group. And once again, we're gathered here. It's Tuesday, November 29th, 2016. And I've got Guy with me here, as you can see. And we're here in the living room lab as opposed to the bedroom lab in the back there that I've been working on. Guy had a look at that earlier tonight.
Looks really good.
Starting to look good back there, and soon we'll have a back room, bedroom lab cam as well to be able to look at some experiments that are running or GANs growths and such things. So yeah, looking forward to having the split abilities there. So for today, let's just move in with Lee Coates and see what he's got going there. He's after my heart with some kind of rotating mechanism, which always makes my head spin. So let's have a look there, Lee. Let me see here. Let's get you set up properly. There we go. Okay, go ahead. What do you have there, Lee?
Well, today I want to show you my fiberglass balls.
Your fiberglass balls. Okay.
So I made up a mold and cast about 10 of them here, or actually 5 of them, 10 halves. And I got a nice, strong spinning ball here. So,
you actually cast these up yourself, like with fiberglass resin, or?
yes.
And is it reinforced resin or just the clear stuff, like?
No, it's got fiberglass in it. There's about
Okay.
I don't know, 5 layers of fiberglass in this part of the ball, and then on the flat part for the rims, there's about there was 4 layers plus whatever
And you use the fiberglass
came up
resin,
from the inside of the ball.
right? You use the fiberglass resin, not epoxy, right? There's 2 ways you can do it, apparently.
Let me adjust my sound here. I can't hear you.
Okay.
That's better.
I was asking whether you used epoxy or the fiberglass resin.
This time I used fiberglass resin because I was almost out of epoxy, but of course fiberglass resin really stinks up the house. Epoxy's better, but it's more expensive.
That's right. It's more expensive. It'd be stronger too, I guess, but it is quite a bit more expensive. It's like triple the price or something, isn't it?
Yeah, something like that. Yeah, I mean, these are so strong. I don't think you'd break them. I think you can spin these at 10,000 for sure.
Yeah, you could probably get 10,000 out of something like that. Yeah.
Yeah, I would.
As long as it's reasonably balanced. Wow, that's pretty cool. So, tell us a little more about where's your mold that you use for it and so on.
Ouch.
Whoops, didn't mean to get you wrapped up in your gear there.
As long as it doesn't.
Stretching your mic cord to the limit on that one. What the heck? Holy cow.
So first you got to make up the mold for the
master mold, like.
the base mold. So these are the acrylic balls I got put in there. You actually got to make it up backwards, and then I put some styrofoam in there and a piece of plywood on the bottom.
Mm-hmm.
Got that all glued together. And for the top here, I used that puck board, or that HD PE poly, and the fiberglass doesn't stick to that at all. It's really nice.
How'd you get the cup forms to form? What did you use?
Well, these are the acrylic balls here inside.
Oh, I see. Okay.
So I had this 1/4-inch plastic, the HDPE sheet, and I've hot glued the acrylic balls to it. It was upside down.
I see. Okay.
Then fiberglass to make the mold.
Wow, that's a bit of work.
Now you got the mold.
Yeah.
So now you lay on your epoxy and your resin and whatever and your fiberglass on that and get it in all the balls.
Yeah.
And then to get a smooth rim top and bottom, then I stuck that on top of that and
Oh yeah.
sandwiched the
Yeah.
rim.
Right.
So that gives a nice even thickness rim.
Right. Wow.
Not too much
And then
shrinkage.
had to
There's
put a
more.
piece of plywood on top there to keep it even, clamp that down.
Yeah.
Then to get it smooth on the inside, I made some little wood plugs on the lathe. So
Oh,
they went
that's
in.
what those are. Okay, yeah.
They went in.
That
So that
keeps
that
the
that
form.
formed the inside of the ball.
He
Nice and
asked if there was any shrinkage, but that would sort of handle that in terms of everything has to stay within the.
Yeah. So
yeah.
then I stuck a
Nice.
chunk of plywood on top.
Wow.
These are all the same length.
Nice.
And then
Good.
any
Clamp
excess
everything.
resin actually squeezed out between that a little
Yeah.
bit up. And that was
Wow.
easy to trim off.
Uh-huh.
So
Holy
quite
cow!
the process.
That is quite a process. Wow.
So anyway, but I'm real happy with the result. So end up with a. Now you can drill a hole dead center in the top when you're using the hole saw to cut the center out, or you can leave that solid. Depends on where you set the drill bit, but
Yeah.
gives you a nice centering hole when the hole saw cuts that hole out. To get
Okay. Right. I
to
see
get
what you're
that
saying.
centered, I actually had another one of these balls mounted on the hole saw, so the hole saw went
Oh yeah.
use
Wow.
that as the center, which worked out good. So that means that hole's dead center in the center of the ball on the top.
Right. Otherwise, you'd
or
have
bottom.
to put it in a lathe or some other way to get it dead center. Mm-hmm.
Yeah, my wood lathe isn't very accurate. So
Yeah, I wondered about that, and I've got a wood lathe, but it's
it'd be
pretty
nice to have
useless.
a machinist lathe.
Yeah, or
So-
even a mini one. Yeah. Okay.
So now what I did with I put the powdered the dried GANTs in with my epoxy mix. So I got
Wow.
CH3 GANTs in here. So I'm just wondering if this is going to give me some kind of advantage. So if I get my, say, lead and CO2 and CH3 inside, I've actually got like a connection of CH3 around
Mm-hmm.
from the outside round to the inside, like it forms like a torus of CH3 GANTs in the spinning ball.
Just the
So-
CH3, eh? Okay. That's
Yeah, so-
interesting. I gotta get rid of
so
this
the-
dinging here somehow.
So I just wanted to run it by you guys. Is CH3 the right way to go, or should it be the heavy GANTs in the outside ball, or the light one, like the light ends up on the inside when it's spinning? So I thought that would give me the sort of a torus effect around around the other heavier GANTs.
Well,
Excuse me.
You should try them all and compare. You got so much more mold now.
yeah.
Yeah, well, you have to cast some more. But
That's a very nice idea. Actually, I like the concept there. So did
I
you
got-
put the dry GANs in there?
yeah, I got dry GANTs powder in with the epoxy or the resin. So I've got a teaspoon of dry CH3 GANTs with
CH3,
I don't know 4 ounces of resin.
Oh,
So
that's brilliant.
Well, it's interesting because now you've locked in the fields of this CH3 GANs, and
Yeah.
while part of it is the release of the hydrogen and so on that might occur normally, you might get some of that happening in the walls. It might actually sort of not degrade, but release some of the hydrogen, perhaps, or maybe it would just contain the fields that are needed and keep them ready to go rather than using the material itself. So it's a good way to feed the center through that skin. Makes sense.
yeah, I thought it was worth trying anyway.
Mm-hmm.
So
Hmm.
anyway, I've had this ball spinning for about an hour here. So
Oh, it's been spinning. I thought it was just stationary.
That's why all the
Okay.
noise.
All
So
right.
I just got the two halves screwed together with some small screws and some hot melt glue in there. So if I
Yeah.
take the screws out, I can take heat up a knife with a torch and actually cut that apart if I want to
Oh, I
open it
see.
up again.
And does this
And
one
then,
have? It's got the one hole in the bottom. How did you mount it to the motor, which is always a big issue for people?
well, I found some
Socket.
plumbing fittings. That was actually
Oh yeah, yeah.
a PVC cap. I drilled the hole out because I'm using a motor here from a weed whacker,
Oh,
and it had a 9/16 plastic shaft around the other shaft, and I said, "Oh, that's good. I'll use that as my shaft," and it worked good. So then I got a PVC cap here and a PVC plug there that's screwed together.
and your
So
your cap that goes on the shaft. How did you put it on the shaft again? It's is it you had a adapter that went on, or
yeah, that's a PVC cap,
yeah,
and
and you
and this
drilled the end.
And this black pipe or this black piece of plastic here, that was on the motor originally. So that's sort of the fat was, I don't know, fastened to the motor somehow. Because the motor had a long shaft on it, particular motor, so it was
Yeah.
good. And I just drilled a 9/16 hole in the cap and
Oh,
slid it
I
on and
see. Okay.
hot glued it in
Hot
place.
glue. Good old hot glue again. I see.
I'm just using hot glue at the moment. Although my motor mount below failed, I had that hot glued up.
Yeah, motors and heat and hot glue, that probably doesn't
Yeah, the
quite
motor
work.
got a little too warm and then it started settling down. So,
Well, that's your
so I
indication.
got
That's your motor temperature indicator.
yeah, but this motor actually it ran it's not hot to the touch. Well, it's warm,
Yeah.
so it's
It looks like a very powerful motor for
so that
sure.
I like that motor. It's gonna I can leave that motor running for a long time. So
How fast does it turn?
well, I had it up to about 5,000, but I didn't have it all the way. So I think this motor will go I don't know 7,000 or something. I think
Probably,
that's
yeah,
Oh.
at least. Mm-hmm.
so.
And how do you
But
power that? You have a weed whacker battery or something, or just through a 12
well,
volt plug-in?
at our sanitary landfill, they have a little junk store there where you
Uh-huh.
can donate your junk,
Yeah.
and they had a whole barrel of these weed whackers outside with no batteries. So I said, "Okay, how much for these?" And she said, $2 a piece. All I wanted was the motor out of it, so $2 for a motor, that's pretty good.
And you just hooked it right up to like a 12 volt transformer?
110? No.
Well, I got my power supply here. It's set at 18 volts, and I got
Oh, okay.
the motor controller here, which I can adjust the
And yeah, what kind of controller do you
voltage on.
use? That's always an issue as well.
I don't know. It's a
It's a,
$6 controller I got off eBay. Comes from Hong Kong.
and
So
it's just a raised
so
pad.
it's got a forward reverse switch here, and then it's got the potentiometer for the
Oh,
the
it's
very motor speed.
it's an actual brushed motor controller then, like a pulse
Yeah,
PWM.
yeah. I'm not sure whether it's pulse or not, but I'm
Hmm.
not sure whether it just varies the voltage or it gives a pulse. But to be honest, I'm not an electronics wizard, so
Well,
don't
that's
know.
interesting to know about that anyway. Very
So,
good. Hmm.
so
So, question is, what do you hope to accomplish with this unit?
well, with just we were spinning balls trying to get a dome
Mm-hmm.
way back 3 or 4 months ago. So
Yeah.
this is just a single ball with a dome. I had that I was trying to make gold out of it but I needed two spinning balls, actually double balls, and my motors weren't working and the balls weren't centered in their acrylic balls and stuff. So this will be good for that project. I just
Mm-hmm.
gotta redo it. But I don't have I can use acrylic balls in the center. There's another one of the car magravs that Mike Nashif and his crew were looking at. They were actually, the center ball was going to have caustic in it, but apparently caustic and acrylic don't agree. So I'd have to make a second fiberglass ball that's smaller to fit in here. So, and if I do that again, I think I'll try and get some silicone rubber casting foam instead of using the fiberglass form.
What about
Better.
what about using a polycarbonate sheet and heating it up? You can heat it up in an oven to make it pliable and put it in your form and just squeeze it in your form, and you'd have your polycarbonate half spheres.
Yeah, if you'd probably need a vacuum setup or something for that.
It's
I don't
it
know.
might be
I
best
haven't done
under
that
vacuum.
before, so
Yeah, it might be best under vacuum. I'm pretty sure. I know you can form polycarbonate quite easily. It becomes really rubbery at about 350 Fahrenheit in the oven, and a thin sheet. If you had like a 1/8 inch sheet or even less, maybe, just almost a film, you could quite easily form it in that form you have there, I think.
it'd be quite a stretch for that sheet to form the ball.
Possibly.
You might want to start with 1/4 inch sheet, and by the time it's in there, it'll be 1/8 inch or less. Like these balls, I think, and they're between 16th and an 1/8, but there's about 5 or 6 layers of fiberglass in there too. So I mean, I think you could drive over them and they wouldn't break.
Yeah, the only disadvantage is they're not clear, so you can't see any processes that might be going on inside, and that's kind of the fun part.
Well, the way I looked at that, I've spun some clear balls. I've seen what goes on inside. So, do I really need to see it anymore?
Yeah,
it's
that's true.
Nice to see the first time, but
yeah, it's better to be able to create some fields with it and measure the fields and the actions there instead of inside the ball.
Yeah. Is it possible to nano-coat glass?
Glass or fiberglass, you mean?
Well, that's where I'm headed. If you can nano-coat glass, I was thinking if you nano-coated the fiberglass that I'm using inside the ball, then you'd have a nano-coated or a superconductor ball, basically. Of course, you can nano-coat the outside and the inside of the ball, but you could have this nano-coated fibers inside the ball if you could nano-coat glass.
The fiberglass is I guess a form of glass, and you've also got the C in there, the carbon from the CH3 and so on. So you have a possibility of making a nanocarbon type nano coating, perhaps. But if it was glass, you can etch glass first of all. Like if you're going to coat glass with copper, for example, or gold plated or something like that, then first you have to etch it. They use an acid, I think, some kind of acid to etch the glass first, and that enables the next you put on a conductive coat of some sort, and I think sometimes they use like graphite, or what is it that they use, some kind of conductor first before you do actual electroplating onto the glass. And that's one way. Say you could electroplate copper on the inside and then nanocoat that. That would be a nice way to go.
Okay, so there's no easy way to nanocoat glass fibers in the fiberglass cloth then.
Well,
that's what I was wondering.
Probably if you just use caustic, it would tend to, etch it the way that it needs to be to have some sort of nano coating that way. I'm not sure.
Yeah.
Maybe it has a natural nano coating in a sense. It's different than the glass as the clear glass substance. Its fibers are, plus the resin and everything. It's a whole different environment than just glass. So
maybe since you built 5 layers, maybe your first layer would be the exterior, could be more induced with I don't know, carbon nanofibers, or you know, something that would just mix with your compound there, like you did with CH3.
It's
Just
an
add up
interesting idea.
Yeah.
an extra.
Put a sprinkle of you know, copper powder on before you press it all together, or something like that, perhaps.
Or I could use carbon fiber cloth.
Yes.
Oh,
Could
wow,
I
that's
ask-
a good idea. Actually, no,
What about a copper fiber cloth?
does that exist? Or like a.
Probably have to make it.
Actually, you know, you can get that fine copper mesh, okay? And actually, you could put a couple layers of fiberglass and then nano coat the copper mesh and put a layer of the mesh in there, and then another couple of layers of fiberglass. So
How
yeah,
how fine? How fine you mean? You're talking about
it's
the.
like 40 gauge or 30 gauge or something.
Oh, really? That's small, eh?
Yeah, well, maybe I'm exaggerating. It's it's got to be about 30 gauge. You buy it at Lee Valley Tools in the gardening section.
Okay, yeah.
They stick
I've got
it
some of
around
that.
their gardens
Yep.
to prevent certain insects or slugs or something from
I think
from
I've got some. Let's see
climbing
if I
up the
can
plants.
Get my hands on it here.
Oh, really? Eh?
I got some, but it's downstairs.
Yeah, I've seen the strips they use, but this is weaving. You mean it's like more like a weaving method, or? Hey Lee, what kind of you're talking about a mesh, isn't it?
Yeah, they call it a mesh, copper mesh or copper. But it's like quarter inch by quarter inch
Okay, yeah, that's
mesh.
the one you have.
It's not like window screen. You know, I don't think I'm not sure you can find window screen, but that's fairly stiff. But this other stuff, it's quite pliable.
Hi,
You
Rick.
find-
Could I ask a question?
Just a second here. Just wanted to. I think this is the stuff you're talking about, Lee.
That's it. Yep.
Right. So
So,
it
yeah,
comes in
so-
a big roll. It's really cool stuff. I thought, you know, if you can just nano coat this whole row, and put some kind of probe, or that would be your reactor in the middle. It's the black hole in the middle. See. And in the middle of all that has got to be about, if this was all nano coated, it's got to be about the darkest place in the universe, right? And if that's true, then it's probably the most receptive place for the fields that are ambient, that get obliterated by our physicality stuff that's in the way, the atmosphere and everything else. So I thought maybe a good place to collect neutrinos or some other tiny little foreign objects.
Interesting.
Yeah, otherwise it makes a good fence too for critters. But yeah, it's basically it's almost like a Faraday cage as well. But you could incorporate that. It would easily bend into your, you know, you
Yeah,
can see how it
yeah.
easily bends into a spherical
you could
shape.
it, no problem.
And it would provide that electrical
Lattice.
sort of connection, or copper connection. Especially, why not nano coat it first and then embed it into your
Exactly.
structure. Mm-hmm.
Rick, you're not recording
Oh, that's
on Zoom.
disappointing. Okay, so I'll have to re-upload or
I
something.
didn't want to stop you, but sorry.
Yeah, I don't have a co-host as well, so I need to do that with somebody. Want to volunteer to be a co-host? Who can do that here? Lee, do you want to be co-host? I guess you could do that.
I've never done that before, but sure.
Okay, shouldn't be too much involved, but it's just in case I get conked out. We don't want to lose the recording that we didn't make. And now we can, if someone wants to record, or Lee, if you want to record, you can, I suppose. Otherwise, I'm going to record to the cloud, and you have to record first if you want to.
How do I record?
I think you can,
Oh, there.
there should be a button there for record now. And that'll record to your computer, not to the cloud. Okay. And I'll record to the cloud. and just say sorry about that cloud, or recording is about a half hour off here, 20 minutes anyway. So I'll have to re-upload to Zoom the other recording. Okay, thank you for that. Appreciate that, Mark. Thanks for being on the ball on that. I should have made you the co-host, actually. Oh well, anyway. Let's carry on. What were we carrying on about? We had
We're talking about the mesh here.
the mesh of...
I didn't mean to stop the flow, but I didn't see the red light in the corner, and I thought, oh, I better stop now.
Yeah, I'm known for doing that from time to time, so...
And I did have a question for Lee, and maybe you too, Rick. I just wondered, you know, because his his spheres are made of fiberglass with actual fibers, and the rosin. What temperature does that? How high of a temperature would that affect? You know what I'm saying? So I'm just thinking if he could drop it in a crock pot heated with caustic in it at 150 or 60 degrees, it might be able to affect it without disforming it. What do you think about that?
Yeah, no, there's no problem. It's
Or would the surface be too smooth for that heat or that caustic to penetrate that, you know, that glazing? You know, like a painter would, you know, take sandpaper to things just to break the surface in order to allow something to go in. I'm just thinking, you know, because I use a lot of heated caustic, and I'm just wondering if, you know, I raise mine up to in the crock pot at 150 degrees and put all my stuff, my plastic plates, my plastic, you know, my fittings and everything, and they don't disform, but I don't know what that's made of. So
yeah, it'll stand up a lot better than acrylic will, that's for sure. So
because I use the acrylic plates, a 1/4-inch plate, or, you know, mount my stuff, and it just warps a little bit. You know, you can just see a little bit of disfiguration, but like the PVC pipes, the Schedule 40, they don't warp at 140 or 150. And then I don't leave it, you know, I drop it in at that heat now, and then I shut it off and let it drop down till it cools off. It's just a fun way to think about how to nanocoat something, if you can't figure out any other way.
I would say there's no problem nanocoating the fiberglass or the epoxy. I think they're a lot tougher than the acrylics and the other PVC that softens up a lot quicker.
Yeah, you might be able to drop it into the crock pot method, as Mark was mentioning there. Maybe you could just dip these in the crock pot, and that would be enough to nanocoat them. It could be.
Yeah.
You wouldn't want to leave them in overnight, I don't think. But maybe
I'd probably cold. Like I do the cold process, soak them in the cold.
In a baggie or something, or
right in.
Cold
dip
caustic.
it in, soak it for, and then I'll put it through my steaming process in the bucket, because I don't think it's not gonna change shape. This is like I say, I could whack that with a hammer and everything else. It's not. It's solid.
Nice.
So
are you going to do some kind of configuration with all these balls? Are you going to set up several of your econo motors there?
Yeah, well, I'll probably redo that gold experiment first. I gotta do a second size ball that fits inside these ones. There's a car maggrav design that has a ball in the center instead of the two balls in the small balls in the center of the coils. They got one in between the coils. I want to experiment, do that experiment, and you know, set them up as in the spaceship formation too, is a possibility.
Right, that would be a good one.
So basically, once I get some motors with balls spinning on the motors, I mean, you can switch out the balls by unthreading and threading back in, and
that's
do lots of experiments.
That's a nice feature.
So
What if you had a gasket rather than the hot glue? That might make it easier to separate and so on as well. But maybe that's not
yeah,
necessary.
yeah, I didn't have any gasket material. I'd have to make these rims a bit thicker to
Mm.
get some more pressure for the screws are holding it together, but they'll strip out the. I thought 4 layers of fiberglass would be thicker than that. It's only about a 16th of an inch or something,
Yeah,
or less.
yeah, yeah.
So I'd have to go about 8 layers of fiberglass. Well, actually, there's probably 8 layers here because the fiberglass on the inside wraps around the top each time, and I got
Yes, right.
3 layers of fiberglass inside and 4 outside. So that's 7 layers, and it's not very thick when
Yeah.
you have to really lay it up with a bunch more layers to get a thicker rim. So, which is that's easy enough to do.
It'd be nice to have something other than the screws there, I guess, because there's probably as much weight in screws as there is in your globe
Yep.
from especially
Yeah, you
on
could
the outside
you could
there.
buy little bolts and then bolt it together, or
You could
or
get
pop
those.
rivets. If you
You
didn't
can
want to
get.
take it apart, you could pop rivet it.
You can get. I was looking today at the hardware store. They had the plastic nylon bolts and screws, tiny little ones. That would be interesting too. And then you don't have any metal involved in the structure.
Yeah, I was just saying pop rivets would work really good for this. Then if you ever didn't, you can always drill the pop rivets out
Mm-hmm.
to take it apart. That would be easy. That would actually probably work better than the screws I got here.
Mm-hmm. Well, interesting. Cool, Lee.
And how did you balance your stuff? It doesn't wobble much. That's the tricky part.
Yes.
It still wobbles there. Whoa! Oh,
Yeah,
now
it
it's
is.
really wobbling.
Yeah, something may have maladjusted from the sudden acceleration.
Wow, that's a pretty.
Yeah, that's.
Oh, okay, no.
It's
Well-
gone off center for some reason.
But then,
Yeah.
I probably don't have it screwed together right here either.
Yeah, right. That could make a difference.
that's gonna help you.
That's how you do your launch control.
There we go. That's
Much-
better.
Yeah, much better.
Just unscrew it and then brake rapidly, and off she goes.
Nice.
Yeah, so I can get up to 4,500. I didn't want to push it past that right now. I might want to stick a box around it or something.
Yeah, you need to have some protection, especially if the
Yeah.
screws in there and that sharp edge. It'll hurt.
Yeah. I mean, having that 90-degree flange on there, that gives you lots of strength in the middle. I mean, that reinforces the
Yeah.
outward push quite a
Yeah,
bit. So
it does.
I mean, there's no way that ball's going to break. I don't think.
Yeah, probably not. Stuff happens otherwise. A screw can come out or something, and whatever.
Yeah,
There's a lot of forces on there. If you could start
a
going up
screw-
into high
You're right.
RPMs, it depends how high you want to go. Like you're up to what'd you say, 5,000 or something there now?
Yeah, 4,500.
That's pretty fast, but it's relatively safe. If it came off at that speed, it would bounce around the shop a little bit, and it might hurt you if it bounced up against you or something. But generally, that's not too bad. You get up around 10,000, it gets to be a little bit scarier. By the time you're up to 20,000, then it's really starts to get freaky with the amount of energy. You realize how much is contained in this thing.
Yeah.
It's like a grinder wheel at 13,000 RPM or something is a lot of energy stored in it.
Yeah, I'd have no problem going to 10,000 with these. I don't think if I had the right motor and the right balancing and stuff. But
Yeah.
what about why don't we have put them on a center shaft with a bearing on each end and then spin them on the motor? Because then you wouldn't have this balance issue.
Well, this is true, but then what you end up having is a bunch of metal at one end, a bunch of metal at the other end, and additional bearings, of course, and so on that are involved. But the main thing is you got this big metal thing that, in the original sense of the rotating reactors, the idea was to try to isolate the spheres, especially from the motors and from other fields and from other matter level stuff that if you were to create the plasmatic field or the plasma inside the sphere, then it wouldn't tend to get annihilated by the matter level stuff that's stuck inside the sphere or stuck onto the sphere and that kind of thing. But it depends on what kind of experiments you're doing, what you got inside, what you expect out of it, what kind of fields and what kind of action are you trying to get with it. To me, you've already got quite a plastic insulator there. In fact, a couple different kinds of plastic: the hot glue, the plastic, the other plastic of the shaft, and then the shaft itself of the motor. You get several removals of stuff from the sphere, and then you got the sphere. And then I was notating about the metal screws that may or may not be, maybe it would be beneficial in a way, maybe it would be a magnetic field that'll move around with it and create something special. But to add a bearing on each end of it is like, it would kind of be like, it kind of wrecks the ability of the fields to get their elbow room.
Yeah. Like I'm thinking you got to go to a bearing if you're going to go to 10,000.
Well, I tell you,
you can put them somehow away from,
away from. You could have a longer shaft.
Yeah. So it has to have a longer.
Then things start wobbling. It gets tricky. Well, I'll show you what, as I've shown before, but I'll just show it again here, which is this thingy here, which I put together. Maybe I was going to move the camera. I'll just zoom in because I don't know if I'll run it here. I've got a video I can show anyway. And let's just zoom in a bit. Okay, so this was my setup I've shown before last week and so on. With it's a little 4x4 toy truck essentially, and it's not focused. Anyway, toy truck, and so I got it, rotating and everything. And here's the thing one of the things that I noticed. Well, I can run it briefly. I had a little trouble here. I was going to show. I've got a battery meltdown. I need to pull the batteries out and replace them. I'd jump boosted it with a 12 volt power supply into my 7 volt, or I think it's a 5, that's 7.5 volt power supply or whatever. Ended up frying some batteries.
You left it overnight, you said?
No, I just left it on for an hour or so during my demonstration this morning.
And then when it heated up the batteries?
And it actually started, it split the battery case here, and this battery goo, it dripped out of it. And
wow.
I'm not sure if it's going to work here, but we'll just give it a go anyway. There we go. So the idea here, similar to yours in a way, but mine much more so, it's very loose. Like the axle bearings in this thing, they're just naturally, really, it's this whole thing is not an exotic apparatus. This is like a $25 toy basically. It's not one of the expensive trucks you get. It's not even 4-wheel drive, it's only 2-wheel drive. And but the point is, everything's loose in this, right? So the bearings are loose. It's on a articulated suspension that moves up and down. The whole thing's sitting on rubber tires on the bottom here. So what happens is, it's got a certain looseness factor from here down. And what I wanted to prove with this apparatus was the idea that once this globe starts rotating, this is the big globe, it's like a 5-inch or whatever.
And full of water.
And full of water, then it basically starts forming its own magrav fields, its own world, its own environment. It becomes number one. And when it becomes number one, it becomes stable. It doesn't vibrate anymore. And everything else below it vibrates instead, takes up the slack, because this actually weighs less than this mass. This mass wins. So especially, even now, just the weight, the sheer weight of it, it wins. But once it's spinning, it's weight. So what happens is, like right now, you see how sloppy that is. It's just sort of bouncing all over the place. You know, it's basically going like this. But once the speed gets up, so like right about there now, I can put my finger on that, and my fingers don't even vibrate basically. I feel very little vibration. Where down here, there is vibration. I can feel it, you know, shaking, and the whole frame's kind of shaking. Not so much over here. It's mostly absorbed in this part through the suspension. So what happens is, just what I was saying, it basically becomes self-centering. And then as we slow down, things start to get a little more turbulent, and you see, at a certain point, this will start to get a little more floppy again. Right now it's there. Right now it's starting to shake and move back and forth, and all do its funky thing again, because it's a deliberately sloppy system. And the sloppy system accounts for the vibration, and that way, well, we might be able to design systems that the ball rotates. Hi, Armen, I guess you're trying to share something there. That the idea is that the ball rotates at high speeds, but maybe the motor shouldn't be so contained, so solidly supported. Maybe we need lightweight motors that vibrate with the ball, or a shaft drive that's a flexible shaft drive that absorbs absorbs all the funkiness, absorbs any eccentricity, let's say. So anyway, I thought that was interesting. I thought, geez, that's an interesting principle. There must be some way that we could take advantage of that, some way that because trying to make everything perfectly balanced is a it's a tricky game.
So it's like it absorbs the imperfections.
Yes, right.
And better you're gonna get it, less vibration you're gonna get, of course.
Yeah, it's nice to have it as
So
close as
your
possible.
goal is to get it as best center, and that's what I was asking. I was asking Rick tonight, actually. Me too. I'm going through the same thing, trying to get my. I never done that in my entire life, but I try to get something centered perfect. How do you do that?
That's right, and I pointed out this instrument to Guy, which was beside him at the time, which is this. It's a dial indicator, essentially, on a stand. And this stand happens to have a magnetic base, so you can actually put it on a steel surface and flick it over to the on position, and it'll stick to the base better, because you want it to be set up. And what you can do is actually, well, essentially, if I was doing it on this, in fact, I can sort of do it here. Let's just do it roughly like this. And
Let it spin faster first.
should be up just a little bit more here. Not sure how that one works. Doesn't matter, it's close enough.
Yeah.
So the idea is that as this spins, you can, I don't know if you can see that moving, it's kind of blurry in the picture here.
Yeah,
And
maybe you
it's
want to
the
shut
light.
this light. No.
Yeah, possibly. I'll try it that way. It might be better, but
It
might end up being-
maybe a little better.
no, it's going to be fuzzy because there's not enough light, and the digital video always goes fuzzy. So, anyways, I need to be closer. It's all. Well, for the principle of learning, let me move the camera. Excuse me while I alter your world severely here. And this a bit higher and we'll be able to see better. Alright, so there's the idea. We've got the the gauge set up here, and you can actually, you can zero it onto the so what happens is this little probe moves in and out and moves the gauge, right? So the idea is you can zero it, you can set these little tabs on here to where you start your needle and so on. And the idea would be to rotate this and watch the what's called the run out, or the difference in the dial. You can see there it's quite a bit of lumpiness, but the problem is the entire unit has way too much slop in the bearings to be able to tell whether or not it's actually got much run out or not. However, having said that, maybe we can try this. I'll rev it up and we'll just see if it sort of holds true to what I was saying about that at higher speeds. Maybe it won't show up bouncing around and so on. So you can see here, you can see there's lots of slop here at low speed. Let's see how it is at high speed. You can see that the case is expanding right there until something got bugged. I think the whole thing's probably moving a bit as well. You can see it's in a pretty narrow range of travel there. So within maybe 5,000ths of an inch or something like that, probably. And right there, it's quite steady as it slows down. But then we're getting big variances, and then when it slows down, it's more and more. Now it's really going up there every once in a while. And toward the end, it'll have the biggest, right there, the biggest extremes.
Mm-hmm.
Interesting.
So it's self-regulating, but still, if you got a wobble, the wobble's gonna self-wobble itself right through the
Yeah,
whole
it's
thing.
gonna set up some kind of vibration.
It's very difficult.
somewhere.
Here you would have to remove that part, maybe put that thing very somehow flat and stable. And
Well, yeah, ultimately it'd be nice to rotate the globe without having a motor attached to it, some other means of rotating it. And we know that the globe will be self-centering if it has a chance to rotate on its own somehow, whether it would be magnetically levitated or air levitated, or perhaps in another fluid outside and you get to rotate it inside the fluid, some other magnetically rotated, or different ways that we could think about that in terms of the rotation. But we do know that the sphere will tend to want to go to self-balancing in a way. They do the same thing in automobile tires. You can put liquid into them that will self-balance the tire. The liquid will form around the outside of the tire and basically balances the
balance
tire.
deformities.
Yeah. So,
Yeah, washing machine spin bowls do the same sort of thing. They're quite often sprung. You know, at slow speed
Right.
they unbalance, but at high speed they centralize right out.
That's right. So we have to distinguish about self-centering that way, or self-stabilization, and the vibration. If there is, sometimes you could have a strong but small vibration. And what can happen in these systems, especially if you have an acrylic ball, you'll get stress cracks that form at the base or other places where it's high stress.
Higher stress.
And these little tiny cracks, you won't even notice them the first few times you run the ball, and then you run it at higher speed or something, and all of a sudden it will just explode because
Yeah,
of...
you're talking about these little hard little balls like that. These are different ones, acrylic
Yeah,
ones.
they're usually the
This is-
two-piece acrylic.
Yeah, these ones are quite different. These are like rubbery here. That's why these ones are much safer.
Yeah, they call these unbreakable in the literature, but of course they're not. But they are quite good. They're made for putting make into a snow scene with little sprinkles and stuff inside, and you put some sort of, you glue your favorite little figurine inside, and then turn it upside down, and the snow sort of comes down. And so they advertise them so that you can do that. They, mean that if you drop it, it won't suddenly break and that kind of thing. They do come in different qualities, though. As I've mentioned before, this is a higher quality one. There's the cheaper imitation one like this. It has a much cheaper bottom. It's just less quality, different kind of plastic, and so on. And as well, these other balls have, the ones I use have an inner liner thing that sits on the inside, a little cup like this, that goes in first, and then you screw the whole thing onto the base here. So it's got an extra, here's one of the bases of, it's really quite heavy. It's almost like a nylon type plastic, and then with the inner liner, and put that on, it's got a extra margin of, you're supposed to glue it all together. You give me instructions with this special craft glue that you use, and so on, the clear transparent sort of like goop type stuff, and that you're supposed to glue it all together. But I found that just putting these things as an insert, as long as they fit tight, I've had one that didn't fit tight as well, and then that seals the liquid in, and then you can put on the other cover, and bingo, you're ready to go. In this case, I just have it glued onto this wheel. It's very simple. I just used some epoxy. In the other case, I used some of that glue that I just showed, and the whole thing just easily unscrews, and bingo, you're ready to go. And you can take out the little doohickey here and put in another Gans ball. In fact, I was thinking I'd try it with four Gans balls. That would be like the Starship configuration, So maybe I'll do that tonight. I'm gonna clean out the batteries, put in fresh batteries, and I'm gonna end up putting a couple of more balls in my unit there, in some interlude, if we ever have an interlude here. Yeah. So anyway, let's fade back here, and I'm going to just put up the camera over here instead of back where it was, and we'll have less trouble with all the experimental things. There we go. Oh, okay. I gotta back off on the adjustment here. Okay, where were we here? Where we got so distracted. Anyway, that was the lowdown on the little car.
Self-centering or
Self-centering was the point there. That's right. So, what do you think about that, Lee, in terms of what you have there and your setup? For example, you might find that you get less vibration if you were to rubber mount your motor rather than trying to glue it into the wooden or into a solid base like that. That's what I'm thinking.
That's an idea. I got rubber carpenters, some sheet rubber. I could put add around the motor and clamp it in there with the rubber around the motor. That would allow it to move a bit.
Yeah, as long as you leave enough room for the cooling for the motor is a consideration.
On this motor, I got the cooling as right to one end, both ends. So I got a this motor mount was for a different motor, so I got to modify it. I just wanted to get it running for tonight to show you guys my ball spinning.
Thank you very much. Appreciate that.
Yeah, but I got to rework the mount here to get ventilation and clamp that motor in good. But yeah, putting it in rubber, that would give it a try. Maybe it'll work like your car there.
Yeah, I'm pretty impressed with the way that worked, because I know that if I would have tried to isolate that motor axle, if I would have tried to put this whole thing in a more solid, I was really unhappy with how loose it was at first. And I thought, oh, this is never going to last, and it probably won't anyway, because it's a cheap $25 toy that's not designed to last. You can get, equivalent ones that are 10 times the price now easily, and even more.
Yeah, what I've been thinking of is getting a bearing at each end of the ball, and then at the one end of the shaft have a flex coupling to the motor, like quarter-inch plastic tube onto the quarter-inch shaft or something, and that way
that's a good idea, actually. That's a good idea. The other way I like to think about it is to have a shaft like this, for example, and have a belt drive on it. So you have a rubber tooth belt or even an O-ring belt can use as well as and that isolates the motor from the drive system, and that's tends to quiet things down and make it a lot better. Yeah, this
I've done it a couple of times, but I found the O-rings after a couple of days they break. So
that's true.
If you want to.
Yeah.
So
the belt drive ones are more reliable, but you have to have everything set up just perfectly correct and so on as well. And if you get up into the really high RPMs, that's when
a little trickier.
Things get trickier. Yes, indeed.
So with these,
you can get on a budget such belts and such gears. If you look for old or broken scanners, printers.
Oh yeah, they got very nice engineer little rods in there.
Yeah.
Last time when I went to buy a new set of ink cartridges for my printer, I found out that it costs more than to buy a new printer of another brand.
That has
always
new
sell on a very low price the new printers together with the cartridge.
Yep, and then you can take all the guts out of the printer and then return it because it didn't work properly.
No, I never do that. But meanwhile, if I cannot anymore supply economically with affordable cartridges, then it's very good instead of electronic scrap to take it apart and to save some very good motors of it.
Yeah, it's totally ridiculous in terms of, there's a printer I just saw yesterday, I think it was $42 for the printer, and I have to go out and pay $65 for the ink. So yeah, it's a crazy world that we live in, where it's cheaper to buy the printer that has the ink than to buy the ink for the printer. Of course, that's what they wanted to do.
That's the sales policy, like it was, I don't know how it is today, but some over 10 years ago, over 14 years ago in Japan, my Japanese manager said, oh, in Japan, you can get a telephone for free just to subscribe for a couple of months of usage, because they get their money from the service. And let's don't forget when the old J.D. Rockefeller, the grandfather of the dynasty, established a very huge customer base for Standard Oil by giving free of charge 1 million kerosene lamps to Chinese.
Oh, that's clever. And then you buy the kerosene from me, right? Okay.
It's same story with the printers.
Yeah.
You get the printer almost for free. You pay for the ink, but every month.
Yeah.
So anyway, you can get very nice bulbs and very nice gears already fitting each to the other. You just have to adapt the shafts
Yeah. Yeah, and they have the shafts as well that might be useful. Long steel shafts. I've got a couple of those actually.
Yeah, I remember I scavenged a few printers. I kind of explored a little bit. I was trying to steal little motors, but they're basically useless. They don't spin fast enough, or I don't know exactly. They need those little control things, and it's pretty hard to dissociate from the whole.
Right. If you're making a CNC mill or something, you can use those parts for exact movements and creating little things that can drill exactly and that kind of thing. But for motors, they're not the best that I found. Yeah, that's right.
Yeah, the motors from the old video recorders or video players, Pastor. And very much made for heavy duty use.
Yeah, I think I've got one that I can show. Just a sec.
When you say video, or Shandor, you say video VHS or
VCRs,
VCRs? Yeah. Okay, yeah, I remember. Yeah,
video cassette recorders.
there's very nice bearings, very well engineered.
Also from DVDs or CD players.
Yeah, let me see here. Pass me that red wire that's over there from the battery system that's right to the right by the vise. It's stuck in the vise there. It's in the vise. Yeah, that one. Find the end of it. Not that end, the other end. Yeah, right there. Well, yeah, just disconnect it there would be good. Actually, probably have to plug in. It looks like this should plug right in. So, let me just show you here what I got. Okay, this is this is an old toy. It's got one of the little what do you call it? CD player motor, which is sort of what you're talking about. And the wires are hooked up to the wiring here, and I've got a little variable controller that's made for lights, I think. And I think it was for LED lights. Let's look into, if I can, without keep coming out. This right here. If it's same, should be. Oh, there we go. We're already going. Slow down, slow down.
That thing spins.
What's that noise? It's not supposed to. Never did before.
That's nice.
Anyway,
it's singing.
Okay, so what this is like I say, it's got the CD motor mounted back here. And instead of CDs, I've actually got CD discs. I've got I think there's about 5 CD discs inside here. And these are actually separated with magnets, I believe.
Little spacers.
Yeah, that's right. I've got magnets inside as spacers for. This is a Tesla turbine. Actually, in this case, it's a Tesla pump. Okay, because it turns out the Tesla turbine can also be used as a pump. You just do everything in reverse. So what I've got here. I did have, before the wire just came off. Just put that back on, it should be alright, I think. And we'll hook it up to our 12-volt power supply that he has found there. I'm not sure why it's making funny noises, but it is.
I haven't run in a while.
I haven't run this for years, in fact, I think. So I'll just rev it up here. As fast as she goes. Still building up speed. What it is, this is a pump. It's actually a Tesla pump. and it's really whipping now. It's probably up around 10 to 15,000 RPM and rapidly rising. Get the tack. I'm not sure if it'll show on that or not. And oh, sorry, it's right here. Let's see if it does. No, I don't think I had anything on it as a marker, so it's not showing up. Okay, anyway, trust me, it's really whipping right now. And it's quiet because of the bearings on these CD players are very nice. No, it'll just vibrate around. Yeah, it doesn't like to be moved much because it's the discs will warp when you move it. And so what's happening is, the thing I wanted to point out, it's rotating at high speed. So this is a Tesla pump, which means the air is going in through the center. I can feel the bit of suction there, actually, not too much, and it ends up blowing out through the hose essentially. So it functions as a pump. And if I was to put a motor on this and rotate, if I was to use it differently as a turbine by putting air pressure in it or water pressure, then it would go in through this hose and make the disc go around, and it would come out through the center instead. So it's just a demonstration of a Tesla pump, basically. So you can turn it down there, Guy, and I just wanted to show. You see how I just move it and it warps the disc. Just want to show how that a little motor like that can actually. Whoa, that's a bit hot though. And with the hot glue holding it in, it's probably enough to. It's probably enough to loosen things up but it's good for a test run. I wanted to see if it would actually function. And the bearings are so good in those little seats. You see how it just keeps wanting to rotate for quite a while there. Alright, just wanted to show that. That reminded me of something I just found the other day, this thing. So that's all I wanted to show on that. And I'll put it away for a few more years probably. Whoops. Although it's a good little control, and that's actually what I need to do with this, is rig up the control with another motor that's not so liable to melt down, because this is a little small for this application. Yeah. Put that away in a happy place. Watch your earphones when you're disconnected. Alright, what else we got on the agenda here? Anybody have something they would like to present or show or tell or talk or debate or...
I got something, Rick.
Alrighty. Is that Zane?
Okay, yes, sir. How are y'all doing?
Pretty good, pretty good. How about you?
Good.
What's up?
Awesome, man. Really awesome. I built this static reactor.
Okay, let me get you pinned and spotlighted.
And I had to take it apart because I had the wiring wrong, but this was a really good lesson. And believe it or not, I was inside my ship, man. I was inside a bubble whenever this thing was first all put together. But I had made a solution of 50-50 sodium hydroxide and KOH, and then I put that in the center of it, and it pretty much ate the ends off of it, the Coke bottle cap tops. I had shrink wrapped them to the pipe, and it kind of like dissolved them really fast. So, but it was fun. It was a great lesson, and And now I got some great ideas for a new one, and everything is being nano coated. But I have several questions and some things that I would like to maybe debate with y'all, or just get some opinions. Okay, first of all, these static reactors. Is there anything that you can tell me about them? The dynamic static reactors. It's here. I'll put up a picture, and maybe I know this will help. Man, I am on to something. And this is great. This is really great. I love plasma. Okay. Y'all see this?
Original Armen's reactor.
Yeah. Yeah. Okay. Well, I'm going to use 4 of these, but the center one it's 3/4 pipe, and the 3 outer is going to be 1/4 inch. But the question I have is I've my magav coils, I've wired them where magnetical is to magnetical and gravitational is to gravitational, and I'm not absolutely sure how to hook it up where I'm going to get more feed to the magnetical, and there's not going to be much back feed to the gravitational. Any ideas? I can put a picture up of the reactor whenever it was completed, and I could put a few up as it was being completed. But well, here, this the dynamic reactor was finished, but I hadn't filled the tube yet, and I was just wiring up the magrav. But I hadn't heard 147 yet, so I didn't know that the magnetical and the gravitational had to be separate on different power supplies. But I believe that this Armen's reactor, I can feed both of them. You know, the gravitational and the magnetical separately, and but okay, let's see here. This was whenever it was completed, and oh my god, man, it was really fun in here. It was really fun. I have a lot of GANS balls hanging from my ceiling, and I'm when I just put a voltmeter to this and started touching it, you know, and make sure that all the connections that there was a pulse, or it was being things were working in it. There was a field, and all the GANS balls started drawing to it. I got like maybe 20, 30 balls hanging from the ceiling, and they were all like pulling to it. And at first I thought maybe I was just hallucinating, because man, there's a lot of weird stuff going on in here. But but you know, I stood up and started walking around, and sure enough, they were drawing to it. I kind of thought that was fascinating. So I knew, you know, we were on to something. And then another thing is, I had um, a container of GANs, of CO2 GANs, and look at how it created the torus inside the container. Can you see that? No. Yes, it goes in and starts going. Yeah, yeah. But yeah, I thought that was pretty wild. You know, um, no, no, it was after that reactor that I just built um kicked on. Once it, you know, once it started, once all the balls in the ceiling started pulling towards it, it was like I could see the fields moving it within a room. It was almost like uh, mirrors of just glass, see-through glass, but they were going in a counterclockwise movement, and I got like three or four real flashes of light. It was really amazing, and then that happened inside that container, and I was like, okay, well, we're on to something. So, uh, yeah, well, I thought it was pretty amazing. It was really cool. But oh yeah, I, yeah, they all pulled towards the reactor. All of them came to the center of the room. They were all just drawn to it. It was pretty amazing. It's pretty amazing. This one right here, man, I can control with my thoughts. It, it's like that fan's moving this way, and I can get that ball spinning the other way. See, it's spinning the other way. It's really cool, man. Really, really cool. I've been really trying to connect with everything, and you know, get my emotions in order, because um I feel that really soon I'm gonna be inside my ship. But um just
Getting
just
emotions in order is a good way to put it.
you know, correcting my wrongs, you know. But but I'm just so happy, man. You know, uh, you know, I don't know.
Right on. Great. Good
Yeah,
news.
I, I just wish more people were working on this type of reactor, because uh, this is the Mercedes, man. This is the Mercedes. This is the Rolls Royce, you know.
Mm-hmm.
But there's only two other people that, well, three other people that I've been communicating with that are kind of on my level, and they sort of understand, and I guess, you know, we're all working towards the same goal, you know, and it's just a matter of creating it and then simplifying it and putting it out there so where everybody can have it, you know. It's
Mm-hmm.
freedom, man. Found it to just it's it's really time for change, you know. The world is, it's so messed up, and everybody's so desensitized, and uh damaged, you know, and it, it, it would just be nice for everybody to get a touch of what it really is like to be free.
Mm-hmm.
But
Okay.
we'll see what happens here in the future. You know, in the next few days I'll have this new one completed, and it's wired the correct way. But I have some questions, and I can't seem to find anybody to help me answer them. You know,
What's your questions then, Zane?
okay, with the static reactor, okay, we have we have a magrav, a three-stacker magrav, okay, and we separate magnetical from gravitational. So there's a magnetical in, and then there's a magnetical out. So there's a gravitational in and a gravitational out. Well, the the main current flow needs to go through the magnetical, and the gravitational needs a real low backfeed. So on these reactors, well, the static dynamic reactors, there's a DC uh, output and well, input and output. And well, here, let me show you. Let me show you. Let's see if I can explain this a little better. Okay, here is the coil that's going inside the tube. Okay, and then here is the nano coated wire going through that coil. Okay, well, supposedly this is AC, and this is our DC, but on the AC, on the inside, okay, on the going in, if we put a little coil around it with a wire poking out, that becomes another DC output. Okay. Now, the magnetical needs to have the current flow going through it. And the gravitational just has to have a low backfeed. But the way that I hooked it up is I hooked it up with my magnetical going into the input for the DC. And then the way that I made these little connectors is counterclockwise to clockwise going into it, counterclockwise out, clockwise going into it, counterclockwise out, clockwise going into it, counter, and so forth, you know, where it was basically just, you know, it would feed it just right. And I don't know. I'm
Okay, I'm
stuck.
trying to get clear on why is it you need the DC? You're talking about a DC output there or DC connection?
Yeah.
What's that for?
Well, inside the reactor was the sodium hydroxide and the KOH. So I know it's creating chaos in there, which is creating a current, a positive polarity, and so it would feed the coils to start that donut, the field. But now splitting them, having magnetical and gravitation separate, I'm not sure how to hook it up where it would have its own supply and it would be correct.
And you're trying to do that through the DC connection to feed that back in as that base current or something, you mean?
Yes.
Have you measured anything coming out of the DC connection, or has any of that been tried? Or is this designed to hook up to the grid or stay away from the grid?
No. This is all just plasma.
Self-contained.
Yes. I want. I, we've been from matter to plasma. Okay. Now I want to go from plasma to manifestation of matter. So the new one that I'm building is gonna have a center reactor, and it's gonna have 3 outer reactors, static reactors, and I've kind of figured out a way to feed the center with a tube and having lead GANs in it, and on the outside of it having like a little ball where it'll draw all the ions into the reactor. And it's a matter of figuring out how to wire it up so that the magnetical gets all the current, and the gravitational is also fed, but it doesn't get a lot of backfeed. There's real low backfeed.
Yeah, I don't know. One thing I'm trying to come up with there's a video there that I had picked out recently. Maybe I could have a brief look at it. Let me see, where was it?
Because yeah,
There it is.
when this one was complete,
Okay.
I was completely astonished. But I knew it wasn't correct. And then Dr. Keshe, whenever he got to it on 147, he started explaining that that the magnetical and the gravitational need to be separate, but and have their own power supplies. Well, with those static reactors, it would be so easy to be able to generate enough from the atmosphere to
Well, maybe there was a video that was shown recently about that somebody had clipped out of the 78th Knowledge Seekers workshop, and I had showed it in the private teaching and so on. Maybe I could show a little excerpt of it here. It might help you to sort of formulate. I'm not sure if this is what you need or not, but let's just have a look at it and see if it's appropriate for the situation here. Okay, let me just do a screen share.
Thank you.
And that's it there, I think. Oh, it didn't work. Just a minute. Do things differently. That's set up, and get my live stream centered on there. Okay, so it was somewhere around here. We'll just play a couple of minutes. Let me see here. I gotta resume this share, I guess. Let me see if that works. Yes. So I'll play a couple of minutes of this, and we'll see if it's appropriate. It talks about the magrav unit and relates it to the 129 Tesla and so on tests. Okay, here we go.
Even if you go to the original system, I'll put this away. Even if you go to the very original system, which we've seen it with all the plasma conditions, and then we saw Alex bringing it to beads, or what do you call it? You always needed a connection to the main. where on the other side you could release energy. And none of you ever understood the process. Maybe we explained it in a totally different way you understand. In this section, you have released and you continuously have the availability of the same thing as this cup. You have created a cup, but in a specific form that it has both gravitational field and magnetical field play. So, go back to the teaching of Ninov, 129. The 129, as I've mentioned so many times, was created because the set with the GANs, which is this, had comparison plasma weaker that it had to feed. And that's how we detected it. So it needed a comparison point that it could act and release upon. When you connect your systems to main, you create this comparison point. You're not tapping into the energy of the main, but the main becomes comparison point for the energy to be available. And now you have a system that compares itself with this point, so it allows the plasma to be released at what the point of demand is. You understand? He's a master and he goes like this. He's been in Italy too long.
Yes.
I'm talking about Marco, he's sitting in front of me. So how you release energy from unit, and you can release energy in vast quantities, is because of the isolation in the frequency of flow. This always follow this, and if you have an AC, it follows this, so it can supply any voltage, any current you need, 220, 210, because it has a point of reference isolation. So you dictate through this what to release this. But don't forget, once you add a unit here, you have created a flow. So the plasma is continuously available at the level of the source. You're working with nano-coated materials, which means the current does not go through the wire, but it goes through the nano layer. Has zero resistance, superconductivity for plasma transfer. So now, in one stroke, and it's now time for a lot of you to go back and reassess, reevaluate.
All right, so what do you think, Zane? Is that relevant? You get
Oh man,
anything?
oh man, oh man. I got it, bro.
All right.
I got it, man.
Good, good, yeah. Right on. So what did you understand from it, or do you want to expound on that a little bit, or?
Yeah. Well, what I understand is that okay, okay, with 3 of these, holy shit, wow. All right. Whatever I have in the center, okay, is that's gonna be my source, kind of, okay? And then whenever I put whatever I need out of it on the AC side, I will receive. So my magnetical's got to go to the back end of my out on the reactor.
I got a question there for Plasma Head.
Is that Peter?
Yep.
Hi, Peter.
How's it going?
Good.
Okay. Plasma Head, here's one of the things that you could try out possibly. We have, been newly doing this, but using CPU emulation for frequency generation, and you can use online tone generation because remember, even the main power is at 60 hertz. So we can use frequency, especially with nano-coated materials. It really generates that flow you want. Also, one of the main questions is, does that generator have a ground connected to it by chance?
No, I'm gonna use lead in the inside. For where first there's gonna be like a ball at the end where it's gonna absorb all the ions. I thought that if I put a tube in the inside and filled it with lead GaNs, that it would absorb all of it. It would actually just pull everything that it could to the lead, and and then pump it out. So, well, I don't. It's a work in progress, man. I got a lot of research to do, and thank you, Rick. Thank you. You got me in the right direction, bro. So, um,
Right on. Sometimes there's just one little clue helps us move. Whatever helps us move to the next step is what we need, basically. And we don't need a bunch of information, just enough to get to our next personal step, basically. Someone mentions, can we use bismuth in place of lead? That's an interesting idea as well. Bismuth is very heavy.
where does that come from?
Son Kim asks that or mentions that. Or where does bismuth come from, or where does that statement?
No, bismuth.
Yeah, bismuth is heavier than lead and safer, they mention. You can get it, you can buy bismuth off the internet. Sometimes it's used as a replacement for certain kinds of solder. Now they have lead-free solder. They'll use bismuth instead. It melts a little higher, I think, than lead, but it's usable. You can make really cool bismuth crystals as well. Look up bismuth crystals.
Okay.
Song Kim says he got his from Amazon, a bismuth ingot. If you look up bismuth crystals, it's probably one of the most beautiful crystals in the world.
Are they the one kind of squarish? They go in the spiral, squarish?
Yeah,
oh, yeah.
that's right.
Multicolored.
Yeah,
beautiful.
it looks like it goes right into another
like a
dimension
fractal.
when you look into it.
Yeah.
So, well, there's an idea. It is safer and so on. Maybe it would replace lead. That's quite conceivable. I think that might be a good way to go. Okay, so good luck with that, Zane, and keep us posted, of course, and maybe by next week you'll have your thing working or something. Who knows?
I might just come see you.
do a flyby at least.
My friend said I'm gonna bounce off the Empire State Building.
Yeah, right. Oops, sorry, miscalculated. That would be quite a newsworthy thing. Saucer bounces off of Empire State Building.
Bring a camera, we want to see it.
Both safe.
Yeah.
Paul G says, if you remember, I was trying to find out if somebody managed to build an off-grid magravs to last the knowledge seekers. Well, I guess that's what we're talking about here, essentially. So it's being worked on. Does anybody else have an off-grid magrav that they're building? He says he needs some advice. Go ahead. What'd you say, Zane?
It's the Oasis system. It's everything. It's your house. It's your whatever.
Yeah, it's all tied together, isn't it? In many ways.
It's just the thing that I was discussing with someone earlier is how do I do the calculations for the atomic weight you know, and in order to figure out the width or length of the structure.
According to atomic weight?
Yeah, well, I mean, of the GANs, you know, whatever the amount of okay. I'm just gonna start sounding retarded, so I'm gonna shut up.
Well, formulate your thoughts a little more clearly then, and we'll go have another go at it.
All right. Thank you. Thank you
Thanks.
very much. I love you, brother.
Right on. Thank you, Zane. Okay, so Paul, perhaps if you want to bring up your question on your off-grid magrav system, maybe we'd be able to put together some advice between us all here.
Hey Rick, hello everybody. Can you hear me?
Yes, hi.
Okay, so what I see so far, the information that we have about the off-grid magravs, it has been posted on a YouTube by Douglas, I think. Is that correct?
Yes, that particular version of the off-grid magrav was posted by him, yes.
Okay, so why don't we put together and speak to Douglas to post all the information that he has so we can all start to build a working magrav so we can speed up the process of delivering these units to the world.
Well,
There's many people that have already been building these magravs based on the two refrigerator unit design, which is now obsolete and so on. And people have been building that for the last probably 6 months or so and experimenting with that with various results. And many people have put together these twin magravs in the infinity loop configuration and are getting results of up to 95% reduction in the power according to the meter. That's already happening, yes.
He was showing in that video that his magrav is working and is producing a lot of power. As I've seen in the video, it's about 4 kilowatts. Am I correct?
Something like that, yes.
Okay, so why don't we take that information and we start building ourselves these magravs and distribute it?
Okay, what have you done so far?
Well, I'm trying to put all the information together so we can make a video.
Well, you've seen the video, right?
Step-by-step information
Wait
on how
a
to build.
minute. You've seen the video. Have you not, do you have your own magravs built yet? There's lots of information on those.
No, I do not have.
Okay, have you bought refrigerator units yet? They're obvious. That's what you need to use.
Yes.
Okay, well then you've got part of it together there, though. So you have to make your magrav units. The information is available for that. You could get together a team to do it. You could get together other people to help you if necessary, and so on. There's people doing this all over the world, and we don't have to start a new movement to do it and start to get all the information together.
It's not about movement. It's about the knowledge that is posted. It's so scattered about. It's all over. I mean, all the information are in this knowledge.
There's a blueprint. There's a blueprint teaching that shows the exact connections to all the units, to the refrigerator units, and to the magrav units, and the whole thing.
That is just a simple schematic. Am I correct?
It's a schematic that shows the exact connections to each unit, to the plasma capacitors, to the magrav units, to each coil of the magrav, to each refrigerator unit, and how they're connected, and how the capacitors in the refrigerator unit, all that's been gone through many, many times. There may not be a central source of that information, it's true.
There was
if that's something you want to work on, that would be great.
The problem is I'm new to this, I'm new to this. And there is some other people new to this, and this is a little bit hard to collect all the information, to to go
Yeah.
all through videos and all these schematics all over.
Right.
We
So
should put
that's the
one
thing
video
about it.
together.
It
We
is.
should put one video
Well,
together
who's gonna put
to
the
make it.
video? Who's gonna take the 2 or 3 weeks to put the video together? That's what I'd like to know. I
Yeah,
can't
I
do it.
know.
I'm too busy with the current stuff. That's now the obsolete
Well,
design
I'm
that we
willing. I'm
used
willing
from
to put
6 months
it
ago.
together.
He's
I'm
gonna.
willing
He
to
wants
put
to
it
put
Okay.
together, but I just need.
Sir, that unit is out of date. It's
Well, that's the
obsolete.
thing. I mean, you by the time you get the video together, how are you going to generate interest in something that's already months old? And now we're moving along to the idea of a solid state apparatus that doesn't need all this refrigeration
Compressors.
For the
equipment.
Yeah, I
for the
think
one who are
the
behind
statement.
though.
Some people have had good effect with it. A lot of people have not had a good effect with it. It turns out it doesn't work well in Europe with the refrigerator systems. They're different and so on, and some certain systems don't work properly, and it's all very sort of iffy and funky. And Douglas, yes, he happened to tune in to exactly the right configuration. That doesn't mean everybody will in their particular location, their particular setup, and all their particular parts and so on, which may or may not be exactly the same as what he had. So I think we have a lot of sort of variables to play with, and that's one of the big problems and issues with this kind of technology. It's not nailed down yet. We don't have videos on how to do everything exactly. Even when we have how to do make GANs exactly, how to do nano coating of a simple copper plate exactly, there's still 100 ways out there on how to do it. We try to make an exact video, and there's still another 100 people will make their version. It'll be slightly different, maybe close, but not exactly the same. And you'll find that people that are experimenting all over the world will have close to the same results, but they won't be exactly the same results. There is no two nano-coated plates that are the same. It's all the local environment comes into play, all the different, what's called, in science and in nanotechnology, they talk about doping, how doping is so important, which is just a few random atoms that are part of the structure will influence the structure enormously. It changes the characteristics tremendously and make it so it'll either work or not work according to its, doping. It's called this little
Islands,
interspersum.
almost like little islands of imperfections that change the whole properties of the material.
Right, so you're going to find that wherever people are making their plates, wherever people are making their GANs, and it's pretty tricky to nail it all down.
I was looking on the Keshe Foundation website, and on the shop over there is a magrav unit off grid for sale.
Mm-hmm.
Am I correct?
Yes.
Okay, why don't we start making that? That it's working, no? Since they're selling it.
Well, it's for sale. It doesn't mean the instant instructions are available to you at this moment. No.
Yeah, there's a lot of people out there that can't build them,
Yeah,
and they don't have
Besides
time.
that, there's a 3-month lead time or something like that. They're still building these units, testing them, and doing all the production and testing and so on. There's a lot going on privately to make all that happen. And we're not privy to all the information. Most of the information comes out in the Keshe Foundation, of course, but when they're working with the factory producing an item, then they have to do their tests. They have to make sure it's actually working properly, and they don't like to release information to the public that ends up being half-baked and half an idea that may or may not work and so on. So a lot of that is kept under wraps until the time is right. As soon as the product becomes available, then the plans become available to everybody to make it, the same as the magrav unit is now. Anybody can make one of these, magrav units that you see here.
That's the off-grid one, or that is the one that you have connected to the grid?
This is the one that plugs into the grid. Yeah, that's all that's available right now until you can buy the unit, but it won't be available to you for several months. So that's part of the way the Keshe Foundation works. People pay up front, wait, and eventually get their products. And that helps pay for the production and keep the whole flow going for everybody else.
Let me say a comparison for those who expect to get a simple file with all the knowledge needed to reproduce a blueprint. You know, women used to get magazines like Burda with such patterns, such a dress patterns. So they can tailor and sew together a nice dress. Yes, those patterns are like is the blueprint file. The pattern doesn't tell you about how you have to choose the direction of the textile, which is very important. It doesn't tell you how to make this kind of stitch, the other kind of stitch, how to do the settings or how to load with thread your sewing machine, and it doesn't say how to produce the thread itself.
Yes, and if you were a seamstress, you would know those things, right?
Yeah, there are so many procedures. It's not about how to put together some wires. Just look back at the Knowledge Seekers Workshop number 30. And now we are at 147 and over. Just look at Knowledge Seekers Workshop number 30. When Mr. Keshe disclosed about how the future plasma components, instead of electronic parts, how we use such a plasma parts or magravs parts, how they work, how to work on nanoscale, how you make combinations of gases and nanolayers, which kind of nanoparticles you can hold within with other ones. So this is the entire game. In a small gas particle, you have like a little sun. It's a source of energy. Compared to our lifetime, it's something which is not exhausting. But you have to know how to hold that energy and how to extract it. So that's why when it was the original blueprint teaching, it was told very clearly by Mr. Keshe that it is not about just we are releasing a pattern or a blueprint. It's you have to follow the entire week of teachings to understand it, how to put it together. So at least please watch and listen to all those blueprint teachings, which were last year.
That's why it gets difficult to jam it all into a 5-minute instruction video or even 10 minutes or whatever. You can put in the basics on, you know, put this wire here and make this connection and use these parts and that kind of thing. But if it's someone just playing around with it, it's basically like a monkey trying to run a computer. You can punch a bunch of keys, but you know, it'll take a billion monkeys a billion years to produce a novel that makes any sense. So
you can get a blueprint of how to build a bicycle with all the parts, all the drawings. Will you be able to make it? That's an information which is for those skilled in the art who are able to reproduce it. But first you have to get your skills in that art, and nowadays it's the art of the new magnet and plasma technologies. You have to understand what you are doing with. So many people are putting together the wires, a nano coating, putting the ganses, and for some it works, for some it doesn't work. Because it makes a difference even how you produce the GANs or how you produce the nano coating.
Or even your intention while you do it.
CO2 kit to produce some GANs, and some have immediately success, and some say after a week it's still not producing anything because they didn't know from the beginning, or they didn't pay attention about how to make the nano coating with all the details.
Some people have spent two months with their kit.
In seconds, and it doesn't work for our purpose.
Yeah, some people have spent 2 months with their CO2 kit and they haven't been able to get the CO2 GANs, which is incredible. But it's sometimes local conditions make a huge difference, and
they have to pay attention about the quantities and the qualities of materials used.
Yeah.
For having a copper plate, it sets copper to all the copper, but some copper, it's an alloy which is very good to be beaten with a hammer and to make some beautiful decoration of it, and it's not suitable for our purpose. It says it's a 99%, but it's a 99.95 or 99.9995%. It makes a difference. It makes a difference what is it is alloyed with it. Some people purchase here in Europe very cheap cables. I don't know in which countries are produced, and they peel them off. So it's just the copper wires. They peel them off, and it doesn't nanocoat. It nanocoats in one section, and the other it doesn't, because the alloy is not pure. It has other metals in it. Others don't take care to clean the surface, to degrease it. During the production of the metals, they use some kind of oils or some lubricants, and recently are not oils which you can take off with caustic, but they're using silicone oils, which is a different kind of thing. It says oil, but it's not an oil. You have to clean it first, or it's oxidized in a different way. So there are so many little details, even for how to prepare properly the surface of it. So we can start to make not a whole video with everything, because people will fall asleep, but we can make maybe new small short educational videos of 5 minutes each or 2 minutes each for those who are in a hurry to go step by step to get on a gradient to reach to the last moment.
So, as advice to Paul, for example, it's a great idea to make a video of the knowledge. In any case, I mean, if you can put something together that illustrates what you understand at this time to be the ultimate reservoir of knowledge on a particular subject or something, that's bound to help others to understand and to be able to move up on their, to elevate them to the next level. So any kind of video like that is always welcome, and we don't mean to be too critical in that sense, but it's just that there's such an overwhelming amount of and variety of information that is coming out that it is literally impossible to keep up even with the latest stuff, let alone go back and recreate some of the earlier stuff. I mean, that's what we do essentially, is recreate earlier stuff in many ways. I mean, Guy and I were just, every time we go through things, we talk about some of the earlier things and try to, because we had some really great ideas back in the beginning times, and they need to be still extrapolated out. And Guy was just saying earlier how he's had these really cool ideas, and instead of just being, sometimes we don't have the time to just expand them out the way we want to, and then a few months later we see someone else is doing the exact same thing and they expanded it out and so on. So this is kind of the way it goes. If you in this technology, it's everybody sort of moves ahead and jumps and starts, and we try to understand as much as we can from our own perspective, but everybody has different perspectives on different levels. As has been explained before, there's people that focus on the nano level, that there's folks that focus on the materiality, the physicalness, the elements, the element gold, the element copper. There's others that go for the nanomaterials, taking the copper and creating that nano layer and using that for various things. There's entire multi-billion-dollar industries just using nano copper and all its different configurations now. And then we get into the creation of GANs from the nano, and the GANs is another sort of higher level in terms of it's got more freedom. The atoms are no longer bound into a grid. They're freed up. They've got elbow room. They can dance. They can boogie.
Around.
Yeah, right. They've got some movement now. So GANs, and then if you take that and expand that to the next level into the plasma water, the plasma vapor, and into the actual plasma, you know, a plasma, and then into the fields themselves and so on, then you start to see there's different levels, and we can, as humans, pick which level we want to have a viewpoint from, and we can, you know, get stuck on different levels because we forget that there's higher levels that we can go to or lower levels that we can use and so on. So if you get too stuck on nano coating, you might forget about the GANs, and if you get stuck on just nano coating and GANs, you might forget that there's fields involved, there's other realms to be investigated, other you know, it starts to get into the feeling realm. Once that gets involved, it becomes non-dimensional. You come into a dimension where it's non-dimensional, where it's no longer associated with a physical thing. You're talking about feelings, you're talking about fields, you're talking about you know, expanding into a plasmatic world, looking at things from a plasmatic or a field point of view, which is different than looking at things from a matter level point of view. So all of this is the problem with these Keshe videos, is it's hard to appeal to all of that audience all at once and still make sense to everybody all at once. This is what Keshe attempts to do and is quite successful with, because people in every realm will get something out of what he says, and it doesn't matter if you're at the top level or at the bottom level. He'll you know, show something or say something that you'll be able to identify with, be able to associate with, or not, in which case you think it's all craziness and probably leave or become a troll. So you know, it's a lot going on that way, I guess. Anyway, you know, please do make a movie if you can, and try to get all the information together. We can all try to help as much as we can, and so on.
Okay, Rick, thank you very much for your info. Also to Shandor, thank you very much. And I will try to do my best to understand the technology and to put some short video so everybody can understand how to build a working magrav. That's the idea, so we can replicate it fast and spread it around the world fast.
Yeah.
That's what I'm willing to.
Okay.
Get in a team, make your draft about the ideas, concept you want to put together. Ask some other friends to review their communities. We have a community.spaceshipinstitute.org or community.keshefoundation.org, sorry. We have so many groups on Facebook and on other social media. So put together a collective with people who have the knowledge and who are willing to and can afford time to help, and it will be much faster.
Yeah.
Well, that's what I'm interested about, to speed up a little bit the process, since we've seen a working magrav which produce that amount of energy. So
don't ask Rick when is he sleeping. When does he sleep? Because he's day and night working all around the clock. You know, there are time differences. We are all around the globe. We are in China, Philippines, Europe, Africa, Americas, and so on, even Hawaii. So,
yeah, that is.
It's need for more people to help in this process. I've seen some very enthusiastic people who put together such a first manual about how to make the magrav unit, but even that contained many omissions and errors, because the sources were not verified ones, just sources were picked at random.
Right, that becomes a problem.
Go back to what Mr. Keshe says.
Right, so if you put something together like a video with different sources, and you may have some slightly incorrect or even reversed information as possible, And so in that case, it can't be promoted as something official from the Keshe Foundation and so on. And that way, it has less audience, and it starts to, you know, it can distort things sometimes. Some people have actually put out incorrect information. We've had to go back and try to correct it or ask them to correct it and so on. So it's a it's a tricky world out there, but certainly people are very welcome and encouraged to give it a go and try to explain to others what this technology is about and how to make it and how to do it. And part of that, of course, is doing our own hands-on experimenting so that we have some basis to talk about when we actually, ask people to do these experiments and whatnot. So yeah, it's a really it's a fascinating game, and it's really the only game in town in a way. The plasma game. It's I mean, what grander and better and more beautiful vision could one have for mankind? There is none, basically. This is the way the universe works. This is not part of the playing around with the physical realm like we've done for eons. This is playing with a different realm, and it gets into a bigger ball game that we are involved in as humans. And it's really, like I say, the only game in town, if you think about it. It's all about human evolution. It's about waking up as humans. It's about consciousness. It's about interacting with your own creations, which is different than it's different than in the old days of the Henry Ford making an automobile and so on. They interacted with it, and they still do in factories, and they're proud of their work, and they have a celebration in the new Tesla factories for each vehicle that goes out. The group gets together and everybody does that little rah-rah celebration thing and so on. So, but it's different now in the creation of these new materials like GANs and using the amino acids and so on. You're starting to get involved with more of an emotional basis, with a connection with these these reactors and with this material and with others as reactors and so on. So this interconnectedness makes it all different this time around. So this is part of what makes it more complicated too, because now instead of me just working by myself, I have to interact with others to get the job done, essentially. And sometimes that means rubbing shoulders with those who you wouldn't normally want to associate with, just because you're of a different type or of a different culture or whatever. And so it might be a little abrasive at first till you learn that, oh, that's just the way those people are from that culture or that typicality or that particular personality and so on. We learn to go beyond that so we can get the job done with this plasma technology. So anyway, I mean to go on and on about that, but I did.
By the way, about the importance of materials, recently I have read posts in one of our Facebook groups. Somebody purchased the so-called distilled water from 4 or 5 places. And meanwhile, he has got a TDS meter, not an expensive one, a $10 TDS meter from eBay to measure the quantity of these total dissolved solids in the water. Mm-hmm. And what he found, only one of those 4 or 5 kind of distilled water had a TDS value about 15. Others had 370, 500, and so on.
Right.
From one petrol station, fuel station, he bought a so-called distilled water, which contained more dissolved solids than his tap water.
Right. So all those things
So
would be coming
don't
out.
always believe what's written on the label. You have to trust the supplier for the quality control.
Yeah.
You have to make the GANs with distilled water. Otherwise, instead of GANs, you get the calcium precipitated from the hard water.
Maybe some water from the tap is actually more distilled than the distilled water. That's a
So
sad,
there you see, there's
sad thought.
so many little details why one have success, the other doesn't have success.
That's right. That's the point. Is there's many variables involved, and we haven't anywhere close to nailed down all the variables with in this technology at this point. There's certain things we
You
know.
know, there are manufacturers of carbon zinc batteries. I don't tell about alkaline batteries, just the carbon zinc batteries, the cheapest batteries. It's not a secret how they are made, the principle. But how many companies, not to say how many private people, can replicate good quality carbon zinc batteries which last 6 months in a radio?
Right.
Always there are some little things of the trade. We
and
are
don't,
in,
and don't
a
leak.
developing phase, of course.
And speaking of leaking, I wanted to just show what happened to my poor little experiment here, which is I left the batteries on this morning, and I had my jumper cables on for the 12 volts, and these aren't rechargeable batteries, and they didn't like to having the extra power put into them. I had them set up for probably an hour or so. You can see that one has split its case right open. They were all very hot. And the one
that's not like it is shown in the promotions on the commercials on TV.
no. And well, you normally don't put jumper cables on your little toys like I do, but hey. And so the bottom one also is leaking, so the fluid started dripping out, and it's pretty dramatic in the middle of my morning private teaching class. But stuff happens, so I'll just dig them out, clean it up, back in action. Jumpers work good. Okay, we've got a couple of comments here. Libby says, another example of how following the blueprints and pattern, I am inspired to make a headpiece like Shandor, but I would need much more than just a pattern. I would need embroidery skills, the details of the fabric used, etc. And each one would vary according to the level of skills of each hat maker. We are expanding outward with each effort made by us. Yeah, that's good.
Thank you. By the way, this is a traditional hat which I got as a present from a friend from Kazakhstan.
Just a sec,
it's
let me
handmade.
get it. There we go.
It's handmade. The pattern is, you can guess the pattern. It's very simple.
Beautiful. Is it wool?
Yes, it's a wool. It's a felt.
Wow.
It's a non-woven fabric. It's a felt made of wool, and it has some manual embroidery.
Yeah, it looks sort of like the infinity loop, but maybe with interaction of three reactors, three entities, three plasma fields.
Yeah, these patterns are going back to thousands of years.
Mm-hmm.
At least 5,000-6,000 of years. You can still find those patterns on pieces of gold which were left over and so on. And these are common to many people of the steppe.
Interesting. In fact, that's pretty much the spiral that we've seen Mr. Keshe use several times. In fact, he made a spiral like that out of nanowire in one of the first children's workshops.
Yeah. By the way, what I was surprised about my friend Rafael Tuleganev is his name, from Almaty, from Kazakhstan, that we never met in life. He saw only my photos, and he found just the right size for my head, which is not very common. It's 61 centimeters around. Most of makers are making up to 58 centimeters only. But he had such a good eye that he brought something which was exactly. So that's also a kind of skill.
Okay. Peter mentions, but what about the percentage of people that need to learn by reverse engineering and taking things apart that would be working units, etc.? The problem is most people don't have time, but there is a solution, he says. Well, Peter, if you have something else you want to discuss about that or bring up, or some other things, that would be interesting. And also, Peter, you mentioned in a comment in the live stream recently something about the frequency to ionize water, at least the etheric resonant frequency of 43,800. Do you want to talk about that a bit, maybe, if you have ability to do so or wish to?
Yeah, I could.
All right, hi.
Hey, how's it going? Okay, so the frequency 43,800, the resonance frequency for water in its liquid state to start reacting and turning into the etheric state. For a lot of things, we can use that with the simple electrode method using the 3.5 millimeter computer jack with computer emulation. Um, that specific frequency would be, I would say, considerably good to have that impacting the waters, like when you're doing your CO2 water, put an electrode in there for a couple minutes or whatever on that frequency. The fielding effect would be that of like a plasma field for the etheric field as well. That's a good one to go at. There's also another frequency for
Now, before you go on, is that etheric resonant frequency, is that associated with how you disassociate water into hydrogen and oxygen with that high frequency way it was done by a lab, university lab a few years ago? Had showed burning water in a test tube using high frequency radio waves. I'm not sure if it was that frequency or not. Or is that different? You're talking about something that's etheric, turns water into etheric water, a different structure?
Yeah, it doesn't. The other way they're doing it is causing the molecular decay between the electrostatic bonds of the molecules, and that's why you'd see it boiling. But the thing is when you just do the etheric component of water, is that it turns the water into a state that's more malleable with anything you'd like to put across it.
So it wouldn't necessarily be boiling or separation occur. It might look the same, but it's changed internally to be more receptive or more reactive and so on.
Absolutely, and it just like with plasma, how the ambient field effect, it does actually increase that substantially, as I found out because I've done a few with the electrode into the little glasses and stuff like that with different types of water, like distilled, boiled, alkaline. I haven't used my CO2 water yet because I only have a little bit of it left, but there is obvious fielding effects because you can actually feel it within the presence when you do that frequency.
Interesting. They did talk about using other frequencies to do sonoluminescence. I was discussing that earlier today in my private teaching class. And for example, you can find the resonant frequency of a flask. Say you got a globe like this, for example, and you can actually calculate the size and calculate the resonant frequency. If this had liquid in it, for example, water, then you would use the speed of sound in water and the calculations for the diameter and so on and so forth. You can actually calculate out the resonant frequency, which for a sphere of this size would probably be, let me see, there's I think 1 liter sphere is somewhere around 11,000 hertz, and a smaller sphere of 100 milliliters was, I believe, 27,000 hertz. So that's 27 kilohertz basically. That's getting up close to that frequency that you talk about. It's still only about half of that or so though. And what that will do is actually form a bubble in the center, or you can form a bubble in the center while doing that ultrasonic, basically high frequency resonance, the resonant frequency of the container, and actually form that bubble, start vibrating it, and cause it to light up to give off a sonoluminescent glow. And I thought that'd be pretty cool to do. But if this maybe this etheric resonance is another one to combine, or another frequency that could be used at the same time. Maybe combined, they both work with each other to make the process, the breakdown process, the ionization actually occur easier.
You really will notice it does help the water for taking on different characteristics. So, and yes, that is, if you add other frequencies with it, then it'll take on not only that kind of opens up the water for the programming, and then you'd put it in like I've discussed with Mark House there. I gave him the idea to do the 3.5 millimeter jack. You just take like headphone cords and cut off the earpieces. You can actually use the little chip in there where the two leads are, but the glue kind of interferes with the frequency. It causes some frequency variance there. So, but you just use the bare wire, tape the grounds to the cord because you don't need it. And then those are your connections for your electrodes, and you can just put them to some alligator clips, or, to wrap it around copper or whatever like that. Another good frequency to know is the actual etheric frequency of copper when it starts to resonate at the etheric level, and that's 464 hertz.
That's interesting. Now, the problem is with the high frequencies, most computer sound systems only go up to about 20,000 hertz or so, as far as their capability of transmitting the signal, I believe. So that might be a bit of an issue. I might have to have a frequency doubler or some sort of system like that. What they do have is ultrasonic transducers. So you could have a little transducer that glues onto the side of a sphere, for example, or I've seen an example with two of them, one on each side, and they'll often be they'll go up to 40,000 hertz. They're usually for one particular frequency, though, so to vary it, to get to zero in on your sphere's frequency or to do other frequencies, that could be a little bit tricky. It's off balance. It doesn't propagate its signal as strongly because it's not in its resonant frequency range. However, it would be interesting to experiment with that, different frequencies, and you could actually use a microphone at the same time to figure out where the frequencies tend to resonate and have your strongest signal at certain peaks, like according to the harmonics and whatnot. So I think it'd be exciting to have a clear sphere, especially one like, any of these, something like this guy has got water in it. Spin it, create instead of a big bubble, create a little tiny, it should be about a micrometer sized bubble, and resonate it, basically oscillate it at certain frequencies, and it could be enough to, under low light condition, start glowing. And essentially, if you can start that glow happening, you've got the possibility for creating, well, some say even a fusion reaction in that situation. An imploding bubble, this sonoluminescence, this glowing bubble, the temperatures can go up into the millions of degrees in this implosion bubble situation. And that's interesting. That's it's a plasma. It creates a plasma. There's no doubt about it. It's a plasmatic structure. It only lasts for a picosecond, a few picoseconds, and that's one of the problems. And that's why you have to make it oscillate. So this bubble goes and vibrates at, say 20,000 cycles per second, and we see just a continuous light off it because it's giving off light every only for a few picoseconds and a few thousand, thousands of times per second, but only for a picosecond or two each time. And a picosecond is a trillionth of a second, so it makes 23,000 cycles look pretty short, actually. So the fact is that we could have that bubble and control it, especially in a rotating reactor, because the bubble tends to go toward the center anyway, and when it's still, it's more difficult. Oops, what happened? My whole picture just conked out.
Well,
Oh,
you
I think
something.
we lost our internet connection.
Everything, really.
Whoa, anybody hear me? Can anybody hear me?
Yeah, the friggin' coil.
Hi, can anybody hear me? Hello.
Nobody can hear.
Hear you.
Oh, you can
Yeah,
hear
I
me?
kind of messed up
Yeah.
there for a bit.
We lost the whole internet here briefly, I think. So I think the live stream conked out. Let me see. Well, it still seems to be streaming.
Damn that red circle.
Pardon me?
It's not about
Oh,
that.
red circle.
Technical
That red
issues.
circle. As far as I know, I'm still operating here. Let me check the live stream, make sure it's working. Well, that was strange. It was a total glitch out there.
It was probably CSIS hacking into my network.
Well, yeah, you should stop harassing them. Okay, somehow. Let me see, is it still live? Is it? No, yes, it's live. I think it's still good. So somehow everything held together through that little glitch and picks back. Okay, so is everything good? People can let me. Yeah, see the old screen share came up, and let me get my screen back on. Back on the second screen here. There we go. Now we're back on live stream properly, and holy cow, things happen sometimes. All right. Now, where were we? Before we so interrupted.
Sonoluminescence.
Yes, we were.
Is it not a cavitation process somehow? Or?
Well, cavitation is implosion, and sonoluminescence is implosion. Yeah, they're definitely connected together. Yeah, that's amazing. The power of implosion in water. It can actually tear apart stainless steel, turbine blades, and corrode them and eat into them,
and
etch
eat
into
the
them.
metal.
Yeah, it
Kind of.
breaks up
Oh,
everything. There's no
you know,
matter in the universe that can withstand plasma. That's what it comes down to. Plasma always wins. Well, I mean, plasma will get absorbed by matter on a minor level, but any kind of strong plasma field, like we're talking about in a sonoluminescent bubble, it basically annihilates matter in that state. It ionizes everything. Everything turns into atoms and electrons and protons and basically a soup. And you can do whatever you want with that soup. You can make any kind of thing you like out of that kind of soup, because you just start picking out protons and electrons and arranging them together. It's just like the perfect medium for creation.
almost like the theory of programmable matter.
Right. Especially if you consider the idea that every single atom, like an atom of hydrogen, a proton, actually, if you get inside of it, has an entire universe inside of it, and according to its position and the forces on it and its lifetime of what it's experienced and everything, because it does last for 4 billion years or something like that. Imagine this thing having this 4 billion year lifetime, and it changes from moment to moment inside. Each atom, each proton will have its unique signature, its unique environment inside of itself that is like an entire universe, according to Harijim, whatever is its name again.
Nassim Aramin.
Haramein. He talks about this recently and has written about it, how this proton, say that's a proton, and we think of it as, just that, protons are all the same. They're the basic building blocks of the universe, blah, blah, blah. Every atom has every element has protons that compose it and all this. But what if we were to look inside the proton And I mean, scientists have done that. They say it's composed of these other elementary particles and, big chunky particles. But what Nassim is insinuating is you go into this proton and look at it. It is an entire, not just a world, but an entire universe inside that has, excuse me, equivalent to solar systems and galaxies and planets and space and everything inside of it, exactly the same as we look out and see the universe out there, and we see billions and trillions of stars, and things we thought were stars turned out to be entire universes instead, and it goes on, and the more we look, the more we find there's even more than we thought before, and every year it seems to double and triple. Well, it's the same thing inside of here. It's the entire universe, and every proton is that entire universe, and at the same time is unique. It's its own unique universe according to the other proton that's beside it. That, well, it's the one that looks the same. Here's one that's similar universe. It's not exactly the same, but it's, for comparison, you got two protons. Actually, one has water, one has air. That's not fair, but imagine these look the same on the surface. They kind of do. If they were all whipping around with other ones, they look like little globes. But if you were to look inside, and even if we were to give the example of water in this one and water in that one, and look inside that water, we'd find out there'd be a whole universe of particles inside that water, a whole universe of microbes and bacteria. And what they're finding now is this one-celled protozoa-like animal in the oceans that's prevalent in all the oceans, and they've only just discovered it. And the scientists say it's like discovering lions when before all you've seen is gazelles and zebras. And all of a sudden this lion shows up and you go, what? What's that doing here? And they just discovered this, and it's in all ocean water, and they didn't even know about it before. So it's like, phew, wow. And so that's part of the signature of that water, and part of, the concentration and the different bits and pieces and so on makes every drop unique, makes every enclosed environment unique. And it's the same thing with the proton, is that I ran into that idea recently and just went, whoa, that's mind-boggling. And so you get inside this environment and you find out, whoa, it's got connections that go out, plasmatic connections, you could say, or field connections that go out to all the other protons around it, and in fact into all the other protons in the entire universe, because each of these is the universe inside of itself, and it's got that connection because universes are connected.
Actually, it's very much like a fractal, but when you think about that old saying, as above so below, when you look at galaxies out there, they're all different. They all have their own personalities, but it's infinitely big, and it's basically the same thing when you go into smallness,
That's right.
and you discover that same fractality to it.
Yep. If on the surface we look up at the stars, and a kid could say the stars all look the same. There's, look, mommy, there's how many stars, you could count them or whatever, and they all look the same. They're all bright things in the sky. Then we look at them closer and closer and go, oh, that one's way different than that one's way different. Oh, they're all different. Wait a minute, these aren't stars, these are galaxies. The scientists all of a sudden you imagine when the first telescope came out and the churches there and looking through and go, oh, no, we can't have this. This indicates there's other creations. Nope, that goes against the laws. It goes against the books, goes against their Bibles. If there's other creations, that means there has to be other popes and priests and other things out there, and we can't have that because we are the controllers of the creation. So that means your telescope has to be shut down. Sorry, Newton. Galileo, rather, or whatever your name is. Prison, and we just want to forget about them anyway. Yeah, whips, prison. and so on. So the story of the human race to the bottom. Anyway, we don't have to go there, but the fact is that we're learning that life is a little different than what we thought back in the old days. This is not your father's physics anymore, or your son's physics, or any physics that's taught in school generally.
Hey Rick, I was thinking for next week's workshop there, because the conversation there today about variables, and with plasma, of course, you want perfection because variables are everything, and you got to really think about everything. Even, look at the ultrasaturation of the air from the chemtrails and nanoparticles. Those actually will affect your plasma making inside your house, because every time you open the door, those come in, and it's full of metals, which the plasma and stuff will pick that up as well. But what I was thinking is, remember at the office there with the fan, the filter there for doing a cheaper version for lab quality air?
Right, yeah. Peter's referring to
Negative.
basically let me get my picture straight here.
That was a pretty cool fan you had there.
There we
Peter.
go. Yeah, he had a basically like a room fan with a filter system attached to the fan itself. Maybe
The
you
back
can
of it?
explain it a bit there, Peter, if you want.
Okay. If you guys just want to give me a minute here, I'll just do a rough diagram of it. So if you guys want to talk about something else for a second, I can just quickly draw a rough diagram so you guys can have something to reference to.
Well, you were mentioning that for some reason. What was the point there again?
To keep
Oh,
the
it's
air,
to
the environment clean. Is it?
yeah, have cost-effective control, to have more variable control on the environment around your
In the
labs
air.
and everything.
Right. Okay. Yeah, that's the main point here. Is yeah, it'd be good to have a picture of your way of dealing with that issue, let's say. And that's a good point, that like most of us don't have a controlled environment as such. The pollen from outside will be coming into our experiments and other stuff in their environment, and there's a lot of stuff in some environments, especially in that heavily polluted city environment structure. You're dealing with all kinds of stuff, everything from body cells from tens of thousands or millions of beings to and animals and everything else, to all the asbestos brake dust and particulates and nanotubes and structures that are part of the pollution environment, as well as any chemtrail stuff like Peter was mentioning and whatnot. It's all there, and it's in our air, and it doesn't matter if you have what you think is the cleanest air in the entire planet. It's still full of stuff, including radon. We have radon is all over the world and in every breath we take. It's in higher quantities in a lot of parts of the world, like Canada, especially if you happen to be around granite, especially red granite, like where my father came from, who died of lung cancer, by the way. But the radon is in every single breath, and I made an estimate in Canada, or in fact in anywhere in the world, the average amount of radon that we take in each single breath is approximately 25,000 radon molecules, or the element particles, you could say. 25,000 per breath on average. So we take in this radioactivity all the time. And of course our body is, it's not like, we're taking in radioactive. Our body has learned to recognize that and use it and take care of it and transform it and so on, except when it's in excess, in which case radon is the second leading cause of lung cancer in the world, behind cigarette smoking. So, and when they're combined, that's even more deadly. So it's interesting that these particles we're taking all the time. We take in viruses, bacterias, and all kinds of yuckiness. And fortunately, we don't have to look at that on a micro level. We probably wouldn't want to, have a video image of everything coming into your lungs at every moment.
You know too much now, yeah.
Too much information. I don't want to see anymore. It's true.
Yeah,
We
it's
don't
part
want to
of
know when we step into dog do if it just wipes off by itself. If you bring it home with it, then you got to deal with it. That's the thing. So, and it's true with many of this stuff that we take into our lungs with radon and all this other. Take carbon nanotubes, for example. Please do. I don't want them. Take carbon nanotubes. They formed in diesel exhaust, and now they're finding carbon nanotubes at the site of kids with asthma, at the site of the lungs, in the actual lung tissues of kids with asthma, and they're also finding it in the sites of cancers, and not just lung cancer, but many organ cancers. And it turns out these carbon nanotubes can form as a seed for cancer, essentially. Now it's funny, the carbon can also be an anti-cancer remedy. So it depends on the shape and how it's used, basically.
Maybe.
Yep, quantity, quality, and entity, that kind of thing. So interesting, though, that the tie-in has now been made between the carbon nanotube world and asthma. So if you add 2 and 2, then mother's mad about kids with asthma. Instead of mothers against drunk driving, it'd be what? Mothers against asthmatic kids.
Nanotubes.
MAAK, MAC, something like that. Whatever the synonym they come up with for this, they'll come up with something to get back at the fuel-producing companies for an imperfect product. I mean, even if you use a diesel fuel product perfectly, you still create carbon nanotubes. That's how they discovered carbon nanotubes to start with, was in diesel exhaust. It was a good way to generate them. They could, all this black sooty stuff ended up having a bunch of carbon nanotubes in it, which is great for if you could sort of filter them out to experiment with and so on. And they were surprised to find these, but that's what's created under the high temperature and pressure of the diesel, burning process, the compression and expansion of the gases and whatnot. So, anyways, geez, Mark, you've had your picture keeps coming in here, and I think it's time for you to get a word in edgewise here, perhaps.
I've lost Peter with the.
Well, Peter, are you there with your?
Yeah, I'm almost done here. I'm just finishing up the last little diagram here.
Okay. So maybe we'll have to wait for Mark, because Mark could get involved, especially if he's lifting off the ground there or something by now. I wouldn't doubt.
Probably floating above.
Had a multi-armed reactor that was, all the arms were rotating and looked like kind of a little alien waving his arms around. Looked like kind of like this little guy with little reactors in the arms and going.
Yeah.
He agrees.
Song Kim asks, what's the best way to create a GANs of a plant, i.e. cannabis? Okay, well, GANs of any plant, one way to do it is you take your GANs, or take your plant material and break it up into, chunky pieces, and put caustic in with it, or put caustic into a baggie, a Ziploc baggie, a tough one, preferably the freezer type bag, and
Liquid caustic, you mean?
put your caustic, dry caustic in, then you can pour some hot water in, just enough to soak the material, the plant material, and Ziploc the baggie and let it sit for a few days, and that will create this really gucky, jelly-like sort of substance. Everything breaks down in caustic, and you can start to use that as your after you wash it out with distilled water and so on. Then you can use that as your GANs of a plant material. It's one way to do it. There might be other ways that people could suggest as well. Okay, are you ready there, Peter? You got something to show?
Yeah, I'm just getting the camera right here. I'm just doing final adjustment on it, and I'll be ready to go here.
Okay.
It's always finding which way the damn thing turns.
Yep.
Alrighty.
Backwards.
Okay, let's get it the right way. Alrighty. Here, I'll turn on my camera so you guys can see, and then I can get out of tests. Give it a sec. It's a pretty jinging camera, pretty old. All right,
Have a signal. It's starting to come in.
Oh, I just gotta do my focus there. Okay.
Okay, yeah, we can kind of see that. It's a little funky.
There, how's that?
Not
Can you put
bad.
me up on share screen? It's a little small on my thing.
There should be able to see it there now. Can you see it now?
Yeah, I just gotta adjust the focus. Come on. Well, I'll just explain it too. Alrighty, okay, so this right here would be just your standard $20, $20 to $25 filtrate air filter. You'd want to go for the red at least because it does everything: smoke, dander, smog, pollen, dust, everything like that. The purple is your microbial filter. So you'd see the purple one or anything higher than that. Going past red filtrate filter, the purple and higher is a little more difficult to install, but it's exactly the same process. Now here's your filter.
You're talking about a furnace filter, correct?
Yeah,
What
just a
people
regular
call a furnace filter. Yeah. Okay.
Yeah, just a furnace filter. Okay, so now here's the guidelines for cutting it. What you do is you cut it right down the middle and then do a little U shape because that goes around the motor part of it, but it folds out and you actually put it on the fan. These right here is where you'd cut that after you put it onto the fan, and then you'd work your way around it. I'll get to that in a bit here. So there's your main guideline. Here's number one right there. There's number one. I'll try to do an upside down two here. That's the best. But okay, so now there's that for the cut lines. I'm sorry about the camera quality, but it's not the greatest in the world. Let me see if I.
There we can kind of see there. Yeah.
Okay. Okay, now here's the filter. You always want to have the mesh on the outside going this way. You want the mesh going this way, so it's on the outside. This airflow will be going this way, and normally the filter side of it would be towards the airflow, but you actually want to reverse that, and that actually corresponds to reversing the charge because especially with nanoparticulate ultrasaturation, all those metals and silicates and everything like that in there are all positively charged, and air is naturally neutrally charged. So the reason why to do that, HARP, everything like that, amplification of signals, So what you want to do is what this does, which is creates a negative charge in the airflow so that it actually comes out neutral. And that's the best for your, would be best for plasma and everything, because standard air, normal O2 is neutral. So here, I'll get out of the light here. There we go. Okay, so you'd want to install it on the fan like this. The cut right here would be on the bottom, so it'll end up right here. And then you'd install it. Okay, so remember, mesh facing away, we'd use just regular duct tape. And here's the grill where you put the front grill on, where you take it apart, the service fan. This is your guide. You don't want to go past that, or else it'll mess up the airflow. Here's the other one. Okay, here's a other one. I'll just adjust this a little bit. Okay, there we go. Just 1 sec. Adjust it up a little bit. Oh, there goes. There goes the neighborhood. Okay, I'll just. Whoa. There we go. Okay, so here's the airflow. Right here's the mesh on the outside of the fan. Here's all the positive air coming in. Now there's 4 different airflows that go on here. It's almost like a dual vortex. So when the furnace filters are inside out from the airflow, it creates that negative charge. And then what you'll see, and we did smoke tests with this to see what it does, the fan will actually discharge neutral air from around the rim, and then it'll go like this. The airflow will go like this. There'll be one conal vortex in the middle right here, and it'd come in from the outsides going into the middle, and then the other one would be coming from the middle here going to the outsides. And now the reason why it bends back here is because of the rapid loss of charge, which would naturally invert the direction it was traveling in. And then what happens is this negative air bounces off the field that's formed here along the rim because of the transfer, and then it comes out in the rim in a circular pattern all the way around the rim, and that would all be neutral air, and it'd be pretty well be double filtered going through that. So the higher the grade filter, you get more microbial. So the purple is microbial because it adds virus, bacteria. The red is pretty much your everyday thing: smoke, smog, dander, pollen, mites, mold, fungi, stuff like that. The purple and higher would be for microbial, and that's what initially you'd want in lab, is also microbial containment, not just environmental as well. I'll do a video here of it because I got the fan here now, so it'll be a little easier with a full video and proper lighting. So I'll do that too and post that probably on YouTube and my Facebook there. I'll also post it on the Golden Age of GANs for everybody to do.
Yeah, thank you. It's an interesting phenomenon where the air seems to reverse back and so on with that filter on there. I've seen that at your place. So
yeah, it wasn't that weird how if I shook the fan like violently in a sweeping motion, how then suddenly the airflow would just go straight through it.
Yeah, it had to sort of be jump started to convince it to go through properly, and that was pretty strange as far as flow dynamics go.
You know, because I've tried it here in my place, but it's not as wide as the office, so open standing, and it didn't have any effect no matter how fast or hard I swung it in the same sweeping motion. So I think containment also has reflectance on charge capacity as well in the immediate area that you're doing it, but that also proves that it's not, like you said there, it's not necessarily the flow, but it's more like the static charge differential that creates the reverse vortex and puts it out into the center.
Mm-hmm. Very good. Thank you for showing that. It's interesting.
Well, hey, for $20, get a $2,000 air purifier. Why not?
Yeah, and if you can put GANs materials in that, or if you were to have a nanomaterial, copper oxide, for example, is an excellent decontaminant for both air or water. Takes out lead out of water within an hour, for example, or takes out decontaminants out of air as well. Maybe a filter,
absolutely. It'd be,
filter that was impregnated with copper oxide might be interesting, even for a house filter, to a commercial version of a house filter. Takes out radiation as well, attaches to the radiation, so that might be useful.
You can easily modify it. Plus, with using the ganses, because of the meshes on the back side of the filter, which is great, so it doesn't stop any filtering process, and it'll actually form a micro layer of GANs onto the actual mesh itself. So it'll give you more longevity.
Imagine if we had had this attached to your mesh and nano coated it. You'd have a nano copper mesh that you could place over the whole assembly. That might be interesting to use as well as a air decontaminator. I mean, that's what they use in nuclear reactors, is copper oxide for the walls of the reactor, so it's the only thing that can withstand the radiation and rebuild itself once the chunks are taken off by the radiation. So it's a good one to use, I think.
That sure makes you think, but I do agree that as with everything, variables, especially environmental variables with all the excess pollution now, regardless of where you are with especially the ultrasaturation of nanometallics, then, plasma is perfection, and perfection is variable and contaminant control, for sure.
Yep. Okay, thank you, Peter. Appreciate it.
Not a problem.
Let's move on to Mark and see what Mark has to show here. I'm going to try to wrap things up fairly soon here, but we'll see how it goes. And if we can keep the flow going, then we'll keep going. What you got, Mark? Your video's been up a couple times. I know that means you're up to something.
You know me, Rick. I just want to say hi to Guy. We haven't had him in the group in a while.
Okay.
In the background, kind of quiet.
Yeah, I missed the group. I had to come tonight, certainly. Thanks, Mark.
We really appreciate you having you here. Thank you.
Mark, you've become invisible.
Oh, sorry. Dun, 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 dun.
Oh no, I thought your magrav was working.
Oh, I wish it was. But I told you last week I'm taking it all apart.
Right, so you're nano coating all the parts of your magrav now, are you?
Yep. It's starting to get broke down, but I kind of kept it, just in case if somebody didn't see some things. It's kind of still in a working order, but this was a decompression week for me.
Mm-hmm.
You know what I mean? I worked hard to get this thing to where it was, and at least we got.
I'm sure. Yeah, that had a lot of parts and a lot of stuff to think about there. Yeah.
Yeah. So and we did see that it got to work and everything, and so and then I had to catch up on our here. Let me turn this for a second so I can see what I'm talking about. I had to catch up on my lessons with 146 and 147, so I did that and everything. Right, we have to catch up and everything. So, but basically, I had to break down this. I broke down my all my GANs over here. My GANs making. I had a great run this time. Whoa, baby! I got a lot of GANs this time.
Yeah,
it was a good run.
That was with your run. By run, you mean like, I think for a month or so you run it, don't you?
Yeah, I do a 30-day run.
Right.
No electricity.
No electricity. Right.
No electricity, just air.
Yeah.
Just the air pump. And the containers are nano coated, or I put them in that caustic solution each and every time. I just read, and down below, the water that I take from that, I reuse it again. Once it comes towards the end, it's reusable. We reuse it So like this run was really nice. I mean, like CO2, I got 4 containers, 6 cups of GANs out of 2 containers, which is really nice. I mean, it's really nice and fluffy. This is only the second wash.
Mm-hmm.
So
Nice fine particulate size, that's for sure. You can tell there's no power usage because of the particulate size. Definitely looks great.
Mm-hmm.
Thanks. And the CO2 or the CH3 came out real nice. Oop, shouldn't have went so fast, but
Yeah, it's hard to keep that stuff down, isn't it?
yeah, it's fluffy. Don't move too fast with
Guy
it.
was saying he flushed his multiple times to try to get the redness out of the water.
I use 3-4 different containers, and I keep, pouring and getting rid of the red things and trying to get as pure water GANs as possible. With the CH3, it's quite hard actually. It's
I
very
don't think
staining.
you can do it. I got all types of CH3, and it just doesn't. This is it. It's iron, and it's strong. And all these containers are nano coated through the 160-degree process that I use.
Nice.
And for some reason, it really holds the GANs in a nice state, and when you knock it, it drops down. It settles nice. So I'm really happy with the run. I still got a little bit more washing and stuff to do, but to go a little bit, because I broke everything down. So, like I said last week, when I break stuff down, I keep it in CO2 GANS water just in case if I need to use stuff again. Do you remember that, Rick?
Yes, right.
Sort of. Yeah. So anyway, what I do is just like all the material, the zinc plates, the carbon rods, the copper pipes I use to make my GANs. I like to keep them in CO2 just because then they go out to the garage and I clean them, and whatever is reusable I reuse. But for some reason, I put 3 of them together. I have a 4 iron wire rod, zinc, iron, and copper in this little bucket here with dimium magnets on the bottom. But check this out. It weirded me out when I seen this. I put because I have a meter on it, and it's been steady at this level of the meter since I put it in there.
And that's salt water in there?
Yep. Right out of the GANs. These 3 materials were right. I didn't do anything. I just took the water. The water is just plain old distilled water. So I didn't really put salt water in there. I just took these, that were up here because I wanted to store them again. And yes, that was the difference. I used CO2 back here, but this one I wasn't going to get rid of them, but I just threw some distilled water in there. And the 3 of them all had whatever deposits on it, blah, 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 blah.
And what are the wires hooked up to inside there?
Just 2 copper wires.
Oh, just 2 wires sitting in there.
Yeah, just 2 wires just hanging in there.
Oh, that's kind of odd.
Positive and negative, and they're just hanging in there. I mean, it's, there's so much amino acid on the top, and there's a lot of stuff on the bottom. But the reading I'm getting just from that.
Yeah,
pot.
it's kind of odd to have 2 copper wires. There's no, gradient there really between the copper. If it was nano-coated wire and a copper wire, you'd think that would have a gradient. Or if one was an aluminum wire and one was copper, one was zinc and one was copper, or one of those other electrodes were attached, you'd think that would be a voltage. But I wouldn't expect a voltage just from the two copper wires there necessarily. So that's interesting.
And the other odd thing is the wires are wicking. Do you know what that means?
Yeah, that could be normal. Through the insulation, it's dripping
Yeah.
through.
Sucking up.
Okay, well that might be why you're getting some of the voltage. It might actually be the voltage you might be getting is the difference between the copper and the chrome plating of the alligator clips. Because you
Even
can
though
have
I got them sanded down, but the clip itself, huh?
you could have a galvanic response there that ends up as part of the circuit. It'd be interesting to have instead of alligator clips, maybe straight wires that would attach to the copper wires directly, and see if they still got the same half volt. It looks like reading there.
About a half a volt. If I just cut it right here and just went copper to copper, right?
Yeah, I don't like to see alligator clips cut off like that, but in a way, yeah, that's basically what it would be. Or get another set of clips and use them for that purpose or something.
I don't care about that, but that was odd to me anyway. That was just an observation.
It's cool.
Yeah, and then look at all that the salt mines back there.
Yeah. Yeah, and that'll probably crawl around as time goes on.
Snap, crackling, and popping.
Oh, yeah. Well,
so anyway, that's just observation. So I'll pull this back. I had a couple ideas, and you even gave me a great idea, and I had a couple of things I wanted to talk about. But first thing is, like since I showed this, everybody is asking me, is that official? What is official about it? What is this supposed to do? How is it supposed to work? And I'm trying to tell people, this is unofficial. We are in the Reactor group. We're just innovators. There's nothing, we took Mr. Keshe's idea and ran with it. That's what he told us, to think outside the box. And that's what this is the technology. Sure, we could all sit there and make 3 stacker units all night long, and everybody throughout the world would have different results. And that's absolutely great. If that's what you want to do, spin some coils and save 15 or 20 or 25% on your electric bill. That's great. That's what that was the purpose. But for this group and the people that see these videos, would just like to say, I don't know anything more than you do. Just all you have to do is keep working, listening, going back to the videos that Mr. Keshe kept telling us to do, like he does in all the teachings. You have to use your mind and be creative. Everything will work if you use your creative mind. That's what it's all about, if you ask me. We could follow each other like sheep to the slaughter. That's what has happened to us all this time. We walk like bop, 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 bop. And that's okay. For the mass, that's fine. It helps the herd to get to the point where we all are happy. But for us who are here in the stuff that I'm doing, I might not be doing the right thing. I might have spent all my time and this will never even work, but at least I'm trying something different. And it's not sanctioned, it's not official, it's my fun. This is fun to me. And if it becomes more or less than fun, I'm not going to do it anymore. I've been down that road before. This has to be fun. Life is fun. This is my hobby. I enjoy doing it. I think about it when I'm away. I buy a little stuff at the thrift store. I think that this might work. Maybe that'll work. We'll see. But folks who see these videos and see this stuff on YouTube and Facebook and all that, I just want to tell you, I started out like you. I am no different than anybody else in this group or everybody else that's watched these things. And all you have to do is use your creative mind to try to do something to help yourself, your family, and your friends. If you don't want to do that, then don't even bother trying. Just go about your business and have a nice life. And all this technology will help you in the end. It will, the rising tide will raise all ships. Whether you try it or not, that's fine. But don't keep asking, is this official? There's nothing official about it. We're creating. We're going this way. We're not asking people to do anything that they don't want to do. If you don't want to do it, don't do it. That's your business. I got to get up and go to work and do stuff. And today I had to rake the leaves and do all this stuff, the manual stuff, just like you guys. So please, we're just people and friends having fun. And if it becomes more than that to you, then I suggest that you just stop and move on. Don't hurt yourself. Don't overthink it, and don't go to bed with a heavy heart and going like, why isn't this working? I don't know. This guy has told me, that guy, that's all. That's not for us to say yes or no about. Our purpose is to just have fun, create, see if it works. And if you want to spend your money, well, spend your money. If you don't, then that's fine too. But that's my tutorial to everybody that keeps seeing me and emailing me and asking me and telling me, is this official or not? It's not. This is nothing official with the Keshe Foundation. This is a fun part of the Keshe Foundation. Mr. Keshe has bigger things in his mind, and the stuff that he does is very pronounced and grand. We're just little people that are having fun and learning, and he tells us to have fun and enjoy and experience, and your emotions will come along with it. And if that doesn't happen for you, then don't expect it. Just maybe you got to walk away. I walked away. I had to walk away. People in this group know that I did. So
yeah, that's a good point, Mark. Everybody's at a different position and a different point in their work. And sometimes, yeah, you got to walk away, or sometimes you feel like walking away and you got to stick with it too. So it's like that saying in poker, you have to know when to hold them and when to fold them. So,
exactly.
And there's a lot of that goes on pretty much a daily basis with all of this technology, because it's so new and so hard to get a handle on in many ways, yet easy to get a handle on in others, because it's in our face all the time. Plasma is part of our lives already, so we just don't recognize it. So
I got a question there for Mark.
okay.
Mark, can you zoom in a little bit more on the middle part with the dual coil on the unit right in front of you? I just want to see, yeah, right there where the two connections are for the middle coil for the outer and inner. Yeah, just down a little bit. There we go. Alrighty, now there's a things with frequency is that, like, you look at a power line, everything like that, the demand for electricity on that line is nowhere near great enough to move the power through that line. So that's why on the electrical lines on the grid, there'd always be grounds, because the Earth's natural gravitational. So what you'd want to do is on the in of the inside coil of the inside around on the horizontal one, you'd want to put 7.83 hertz, because that's the gravitational field for the Earth's energy pole. Then on the in for the outside vertical coil, you'd want to put 9.6 hertz, which is the Earth's magnetic field. And then that'd give you two Earth gravitational and magnetic. Try that and see what type of reaction you get, because with a cross vortices like that, you should get at least a few vortexes in the middle component there.
Cool. Did you see the complete? I understand you're a calculator and you calculate things. So did you see the whole unit working before?
I saw a quick clip there, not too much in detail, but I do remember everything spinning and that was great. And that what I told you there was one of my initial ideas about it, because the middle coil there would be the base component for the horizontal and vertical axes for even the spinning Gantz. The field would be centered there because of the two colliding in that XY pattern.
Right. I have actually, this is a 6 motion unit with 9 actual core. I mean, I got like I said last week, if you want to do the calculation, it would be incredible. And I haven't even elaborated on what this part of this whole unit is. Do you even know about this? The blue tube here? And what's coming out here?
Is that going to be the plasmatic flow, or are you actually going to have any type of Gantz or Gantz water in there?
It actually should be H3
Supply of hydrogen.
It should be a form of hydrogen, an off gas of what's going on inside the pipes. So I don't know if it's going to be an H3 or an H2, but at least it'll be in a gas form, because once I fuel the bottom and I have the actual rod or the actual linkage inside that makes actual Gantz inside the pipes with the nano coating, the off gas, that's what I was worried about, off gassing, is that I can at least control the hydrogen that's being, whether it's being H2 or H3 with the valve. I want to direct that plasma energy into the middle. Does that make sense to you?
Yeah, you got some input control for the excess or for the flow there, and as what the valve would be there for another controlled variable.
Exactly. So with each outbound rigger at variable sizes, I'm creating the apex. Hopefully, I create the apex in the middle because of each small magrav unit that goes on here. It rotates the field to the middle. So if you can just imagine the two wheels turning with outbound mini magravs on it, it actually creates field, and the apex of both outbound fields should end up in the middle.
Okay. How you connected your coils?
These are your connections, Armen.
No. That's not a connection. It's not a point. How you connected? You connected the gravitational to gravitational, or just a simple way, gravitational to magnetical?
Just like we were taught.
Yeah. Let's say one coil, inner coil and outer coil. How you connected?
Well, if you want to start from the top.
No, just explain one coil. You have two coils, one gravitation, two coils in a gravitational and two coils in magnetical, correct?
Yes.
So how you connected that gravitational inside there is another coil, correct?
Yes.
There's two coils. So
yes.
how you connected?
So what I did was I took the so to start from the outbound in to the small inner coil, which would be my first connection. It goes to the inner coil, goes into the inner coil, comes out, and then the single line comes back through and then comes back out, like we were told, which then goes to the inner coil of the larger coil, inner, all the way through the single line, all the way through, which is now the inner coil is now connected to the outbound inner outside coil, and now sends through the outside coil back out to the outside coil here, which
Okay,
is
just the simple way as is in the blueprint, correct?
yeah, yes.
Okay, but let's think totally different, because this is the point that when there is a blueprint, nobody thinks, because it's amazing. 1 minute.
I think.
Okay, here, if you have one coil, which is inside, this is just a gravitational coil. How about you create clockwise, anti-clockwise the outside and clockwise inside?
On the middle coil. And
Yeah,
the inner
and
coil.
there is another coil, which is the outside. The
Correct.
same way you do the opposite,
So you want me to connect the inner?
No. Even the coiling is different.
Oh,
Okay, one goes one way, the other goes the other way.
Dual vortex.
Clockwise and anti-clockwise. Then the same thing is outside. Now what you do, you connect your gravitational to your gravitational, from gravitational in, going out to another gravitational and coming out. And if you have third coil or second coil, you just continue that way, only gravitational. Then we connect the magnetical the same way.
mm-hmm.
Now you have separate control for your gravitational, I do red, and separate control for your magnetical, which is 2 lines, and 2 lines for gravitational. One is in, one is out, one is in, one is out.
Completely separate.
Completely separate. Now let's consider it's a one coil, so it's easier to do one coil. I'm not doing the stacker, because then I will connect the gravitational to another coil up and bring it down. Now still I will have 2 ends, the same way for the magnetical. Now you can control. If I have a battery and I have a regulator, correct? Depends, how much energy I will put into the gravitational and how much energy I will put into the magnetical. Even your connection here and here can make a big difference if you connect this plus, or you connect this minus, or you connect this minus, you connect this plus. So try this way. Nano coat your whole, coils perfect, and GaNs coated. Heavier, lighter. Look, this is the proton, this is the electron, this is the neutron. They're all the same. It's a mass difference. You have a CO2, or you have a CH3, or you have a copper, or you have a lead. Try to understand. Even in atomic level, they work the same. If you have a lead, neutron, proton, or electron, they're the same substance. But they still rotate, hold on each other. Correct?
Yep, exactly. So do you want to see what I just made? Because I got caught up with 147, and I understand just a little concept. I was just watching Renan as he was spinning the ball in the sandbag, how he lifted like that. And now I know, Mr. Keshe woke you up at 2 in the morning to try to demonstrate. So I just made this thing, and
it works perfect. I done it. I was so that day I couldn't even talk.
I know. So look at, maybe you can just might want to maybe you could comment on this little device that I maybe have stumbled on that. I don't know, but this is what's going on the bottom of this. So
I did.
yep, he did. So what I made, Armen, was we learned that heavy rotation. I'm scared of those balls, those big plastic balls. So what I did was this is just fish line, and what I did was I drilled.
Yeah, I understood what you did.
So
you need one. You don't need 10.
Pardon me?
You need one. Oh, you want to do many electrons? Huh?
I'm from Detroit. I need a lot more than that. I'm a little cookie.
That's where the saying came from. If an inch of chrome is good, then a foot of chrome is better, right? So makes sense.
I kind of think so. I mean, these engineers and designers. I'm surrounded by all these I'm in Detroit. Like these people are all screaming in my head, "Hey, yeah, make this." I don't know what I'm doing. I'm a painter. So anyway, so hopefully, I don't know how fast this is going to go, but I made from my Ganses, I made two CO2s, two CH3s, and two CUOs, and lead. And my first thought, and Rick,
you don't have you didn't set up your gravitational. Now you have all this mixture. Now you should have a mixture of it in the center of your motor.
Against the motor with lead.
No, all the mixture, because now you have all the CO2, lead, everything in separate, correct?
Yes.
But if you have it in the middle, more bigger ball, that means it's going to be gravitational. So just understand.
Put a little hook
this is
here,
like
a
electron
hanger here. I got you.
Yeah, but you have all the electrons, but you forgot about the proton.
In the middle.
Definitely.
Right here.
Yeah.
Okay, no problem.
Just understand.
Like I said, I'm small.
You don't have to call yourself small, because at least you are doing and you're trying to understand. First of all, that's a huge thing. And thank you for that. But just understand proper way. If you understand one time, then it's going to be like a childish game for you. Just this is proton, this is electron, this is neutron. Mr. Keshe explained this very beautiful. They all the same. We have our sun. All these planets came out from the sun. So they are the same.
Well, that was what I was hoping that I could kind of accomplish, is that when we first look at things, it's in a square form. And round has to fit into square. So if I get a 6-sided square and feed it with, interlocking loops, that's what I was hoping for with this unit, is that the apex of all 6 units would end up in the middle, which would actually create everything that we need right in the middle. And then we're live. We should be live. I don't know. That's just my intention. I'm just, like I said, Armen, I'm just having fun like you are, and I don't know what I'm doing. And we're trying, and I'll take that suggestion of putting something in the middle here. That's a great idea. Thank you very much.
So, Armen, our gravitational is the inner coil, and our magnetical is the outer coil, correct?
Correct.
So so for the flight system, whenever we're connecting them, it's the inner coils connected together, and the outer connected together. They're not the inside gravitational coils connected together.
Okay, let me tell you one thing. If you have a ball, correct?
Yes, sir.
This ball, it's separate. You separated it with matter, okay? And inside is a plasma. Now, the outside, you separated the matter. Inside is a plasma too. Now, you hold two plasmas together. One is heavier, inner. Outer is lighter, like electron. The same thing in a coil. Now, if you control it separately, meaning you can add to the gravitational, or you can, add to the magnetic. In interaction, you create the interaction between two.
Yes.
Out of the interaction, there is a residual. Without the interaction, there is no residual. Without interaction, you cannot see the light from the sun, because we see, when we are in our atmosphere, from inside, we see the light. Because it's the interaction between the magnetical field of the Earth and sun's magnetical field. From inside, we see the light. If we go out of the atmosphere, we're not going to see the light. We're going to see darkness. And the sun is like a, fireball. Correct?
Yes.
So they just, you have to create interaction. If you have all the coils going same direction, where is the opposition?
I understand.
We came to this point to explain people GANs, it takes time. A lot of people, to understand, to come to this point like you guys, to try it. Try to understand differently what you are creating. If you don't create the interaction, how you want to start something?
Okay. Can I ask a kind of deep question?
You can ask any question you like.
Okay, how do I feed it with a static dynamic reactor? Actually, I'm gonna have 4 of them, but there's a big one in the center, and there's
just try one. What you go for?
More power.
Try one stack, just one coil. Gravitation, magnetical, gravitation. Just one coil. See what you get out of it. Just try to understand what you quote here and what you quote here.
So why heavier and lighter? Heavier and lighter.
Correct.
Potential difference.
No. Here, this is heavier. This is lighter.
Right.
Of the same.
Residual.
Of the same. You can do 1 GANs. You can do 2 GANs. You can do 5 GANs. You can do 100 GANs. It doesn't matter. The sun is, all these fields, what you see in the matter level, it came from the sun. If there is no in the atmosphere, how are we going to absorb it?
Yes. Right.
Correct?
Yes.
So you create a condition. Start play with it, differently. We're stuck in one place because of these blueprints.
Yes.
Going crazy.
Yep.
But the blueprint is not, it's just step in. Like people like you to come up and start to think.
Yeah, get out the box.
Mm-hmm. That's most important. Doesn't matter who brings it up, who's gonna do first, who cares?
Right.
The importance is, like a lot of people like you, they start to test, they start to understand. Otherwise, how? One person gonna show one thing and everybody gonna copy it.
Yeah,
They're
dude.
never gonna learn.
Yep.
And that's bad. I can see. That's why, you know, we drag them to the point like people can see, can understand, and they can do different ways, you know, not the way it's been said. Okay.
Thank you, man. Thank you so much.
You're welcome.
Very good, Armen. Is there anything else you want to add to that at this point?
Just understand. I'll explain one more thing. Look as hydrogen. The deuterium. It's a tritium. Lighter, heavier, heaviest. Neutron, proton, electron. Every, let's say, 7,000 hydrogen atoms, there is one deuterium. Look how it's spreaded. How it diluted. If our conventional way, if you create the hydrogen, you boil the water, let's say you put electrodes in there and you boil the water. It's not boiling, actually, it's just, you know, releasing hydrogen so much that even the water goes down, you still add, then you just, you know, maybe liters of water, you get a little bit deuterium. Correct? Make it heavier.
If we stick the FE in a blender and crank it on high for an hour or so, in intervals, will that help create the three?
No,
No.
no. There's different ways to create deuterium, but let's not go there first. Let's understand what is. We have the gas. Doesn't matter. You have different. You have copper. You have CO2. You have CH3. You still can create interaction. Depends how you're going to spread it.
Yeah.
How you're going to dilute it. Let's say if you have 3 cores, heaviest, heavier, and lighter. So you have the connection. It's the same, correct?
Yes.
So where this flow is going to go, you dilute it more, you dilute it more. Water is heavy, lightest, deuterium is heaviest, tritium is more heavier. But they're all the same. Same substance.
Same from the viewpoint of number of protons and electrons.
Yes.
For
The
electrochemistry.
mass, now you're talking mass. We're not talking about that. I'm talking if it's copper, if you have, you know, 3 different states, meaning lighter is electron, heavier is proton, and
Neutron.
heaviest is, what is it? Tritium. But this is Cu. Oh.
So when we talk about the isotopes, it's the number of neutrons which is different, and consequently the mass.
Mass is different. In plasma is a mass we're talking. Forget about the rest. Talking about the field. Heavier field, heaviest, lightest. By mass. Sun mass is bigger, but we are part of it. Even us, part of it. We contain every single material what's in the universe. In small quantities. 78% our body is hydrogen, the rest of it is oxide. If we burn your body, you know, how many grams of ash you're gonna have? Where's the rest come? Didn't disappear.
Evaporated.
No, you released it. Hydrogen, you released it. It's the lightest. That's my dog snoring. English bulldog, my God. So, I hope you understood a little bit more. Try it. You will see. If you don't create an interaction, how you wanna see anything, guys? So try to do different coiling, different connections. Don't go with one connection to see something. You show. When you nanocoat the material, so this is the point. Just understand, it's simple. You have a matter. In matter state, plasma is so tense that all the molecules, they are sticked with each other, and their interaction, there is no interaction. There is interaction still, but they canceling each other. Why? Because they are so tied up with each other that no field going out. But when you nanocoat, what you did, you created gap. What happened? Oh my God. You created gap bigger. Still attached to the matter, but in your interaction, see the gap? It's more. And there are millions of layers. So that's why when you touch it, you can, you know, measure some voltage in it. How come? Where it came from? You're not putting any electricity, but you're measuring it. But in a matter state, you don't measure it. Why? Because I just explained, they are so tight with each other that they don't release anything, hardly release anything. Now you have in GaN state. They're not attached to matter. They are free They manifested from the gas with the oxide. You can see against. Each that you see, the matter, because it's visual for you, it's manifested itself because out of the fields. Or you released it. Now each individually, they radiate energy out and they absorb energies too. Now you have millions of it. Billions of it. Each is unique because it's slightly different than another one. Then understand how you do. If it's the same, create heavier, heaviest, heavier, lightest. So if they're same, they will interact. Mix the GANs together. It's still the same. We're talking fields now. You keep thinking about the matter. I'm talking totally fields. If I'm mixing together, now I'm a mixer of the fields, but if I dilute it, I'll still be connected. Any comments or thoughts? Or total silence? What is it?
Guy
Armen,
has something he wants to say here. Go ahead, Guy.
Who?
Guy.
Oh,
that's me, Armen. Nice to talk to you. I haven't talked to you in ages. Are we talking about ratio here when you're saying this? You're talking about the heaviest, the heavier, and the lightest.
mass difference. What's proton? 2,000 times bigger than electron.
So that would be a ratio right there. So like, can we use this as a scale, like you know?
Definitely.
Oh, okay. So that would be the dilution ratio, pretty much.
Correct. So easy.
It's like mimicking the universe. I got that phrase that Rick put right above the computer, and we're reminded of this. You know, you were describing your little expose here, and I was just looking at the planets and you know, the sun revolving around the heavier and the asteroids, and you know, basically we're mimicking the universe, but it's looking at it at every scales, and the magrav, depending of their mass and their ratio, the planets are all sitting into ratios basically, or fractions, very
Correct.
perfect.
It depends where it started, what kind of fields were available in that time, correct? It starts its journey, pulling into the back to the sun again. But in his way, he's gathering all the fields, what is available in that particular time, correct? And
Yep.
condition. Until it gets back to the sun.
Amazing, yeah.
What is it?
I said amazing.
Yeah, it is amazing. You don't have to, just, do it because of fun. Do it because of fun, but understand what you're doing, then the real fun will start. This is what I'm waiting. One do is no interest. A lot of people, they will, oh my God, it will go so fast that everybody will. Only the point that, don't stick on something when they show. Try to understand different. Don't stick on one thing. Oh, this is the way it is. We have to get it done. Change the direction. The interaction. Matter state is beautiful that you can shape it the way you wanted it. And matter is you're holding plasma, your nano-coated material, because it's absorbing everything. It's like holding the plasma. Correct? If you put GANs on top of it, now you have additional, not what only is in the environment. Now you have touched ongoing energy on top of your plasma absorber. Because now you have heaviest, heavier, and lightest. In a matter way, it's totally different. In matter, this is going to be heavier, this is going to be more lighter, and this is more heaviest. So, more lighter, actually. I'm talking 2 o'clock.
So you're talking in terms of heavier fields rather than the matter level.
Yeah, this is lighter field because it absorbs everything, correct?
Think about that one a bit.
More questions? Or if you did not understood, I can explain a few other things.
Anybody have any questions for Armen?
Plasma moves through plastic, right? I mean, plastic doesn't affect the fields.
Your matter is your containment. You can hold the plasma. It's copper, coil, or the ball. No difference. Nano-coated, not nano-coated. Has no difference. I'm talking even the balls outside. Because now you hold the plasma inside. Copper coils, you have to nano-coat it because, you have to hold the plasma because it absorbs the fields. Now, if these coils you understood, now you can control the energy input or output. You have 2 different batteries to control. Increase it or decrease it. Increase it or decrease it. What you get in between is the interaction of 2. actually interaction of 4, not 2. When it's silence, I love it. A lot of people thinking. No more questions?
Pretty quiet crowd there tonight, Armen. Hard to get a laugh out of them.
No, I was laughing. This is really.
Hi,
Thank you. To get us going.
Okay, the inner gravitational coil. How do we tie the gravitational coil to the magnetic coil?
You don't
Just
tie it.
cross it?
You don't tie it. You connect here. If you have, let's say this is, I will try to do it properly, that you understand. Okay, this coil goes 1 turn and comes out, correct?
Yes.
Oh my God, this is disgusting. With 1 finger, this is as good as it gets. Okay, and this coil, it goes inside and comes out, correct? Now, this one, connect this one. Okay, now you have 2. This one, connect here. Now you have 2. Let's say this, you connect separate battery, plus, minus. This, you connect to the separate battery, plus, minus. With the regulator, that you can regulate how much energy you can input. Outside coil, they are nano-coated, they are insulated. So, increase here, 10 volts. Here, 5. Or here 5, here 10. What you do? This all the fields, they interact with each other. Create this clockwise, the other one magnetic anti-clockwise, or this one anti-clockwise, this one clockwise. The same in here, bigger coil. One goes one direction, second goes the other direction. Look our Earth. Inner core and outer core. Look our moon. You know, moon, it rotates anti-clockwise or clockwise. Do you know it? It rotates anti-clock. The same the Earth. But inner core goes clockwise. To create the interaction, to have atmosphere. Same in the moon. The same the sun. Same. At least, let's say there is a planet, inner core it rotates anti-clockwise and outer core rotates clockwise. So, change of polarity. Any comments? Objections?
How about questions? Somebody recently asked in some group chat about what is the specific role of that continuous wire which goes through the gravitational coils. So we have the inner thinner coils which are then continued once more within and then comes out.
You have the loop already inside. Even the gravitational, even you have a loop. You have a third loop. If you look at it, one, correct, the coil, and there is another coil. What is this? The three.
Yes, indeed.
Heaviest, little bit less heavier, and the lightest.
It's in the same sense, in the same direction with the inner coil. So it adds to its gravitational magnetic field.
No, this one goes anti-clock if you look at clockwise. If you look at it, you bring it in clockwise and go outside. Correct?
Yeah, in the same way as it goes the inner coil, the thinner one, same it goes that one wire loop.
Yeah. It's a one loop already there. That's your hold.
I think it adds a little to the fields. So to bring the fields a bit higher, then it is dictated by the number of windings.
Number of windings is interaction. More interaction, more fields you're going to get out of it. Like I said, in a gas of millions and billions that you created, each them are different. Even they are same from material, but still they are different. Slight difference, it gives you more interaction. If they were all the same, how is it going to be interaction? There would be imbalance. That's why every star is a unique. Because if this is the sun, what happened? This is the Earth. This is other planets, Mars, Jupiter, and the rest. This is the beginning, where it starts in here, where the weak fields go out so much that it's weaker, and there's the opposition of fields of galaxy. These things are unbelievable. Now it's doing crazy things. Oh my God, again. Okay, that's fine. Here's the start. Here's the galaxy. And all universe, all the fields are weakening in here. Because it's from the sun coming the fields. And from here, it's a start of new planet. Clouds, all the gases. So when they start to pull in, their journey in this time zone and in this environment is totally different fields that the planet is absorbing. It's coming here. In here, it's totally different fields the planet is absorbing. Here, it's totally different. The environment is different. Mass is different. That's why here we see dinosaurs, here we don't see dinosaurs. More we're gonna go in, everything will change. In that time, life is gonna be totally different. It has to. Until it goes in and start all over again as a field. So it's all the same. They all interact. This interact with this, this interact with this, this interact with this, this interact with this one, and all of them, because of they are the same, came from the source, so it's the same. Now, if you have 1 GANs, or you have 10 GANs, or you have 20 GANs, doesn't matter. How you want to dilute your fields? By mass ratio, this one is the heaviest: neutron, proton, electron. deuterium have one neutron, one proton, one electron. It's heavier than water. If you create the ice cube of the water and put it in a glass of water, what's going to happen? It's going to float or it's going to sink? Do you know? Anybody can answer? Any clues? It's going to flow. But if you have a deuterium, it will sink. Why?
Yeah, then it's heavier.
Hmm?
Yeah, because it's heavier.
Correct. But it's the same. Hydrogen.
Yes.
Just imagine about tritium. Any more questions, guys? It's 2 o'clock.
Yeah, I think we need to wrap things up here shortly. Thank you, Armen. Great teaching.
Yes,
Thank you, Armen.
Thank you, Armen.
Thank you, Armen.
You're welcome, guys. Have a good night.
Okay, get some rest.
Thank you, Armen.
You're welcome, guys.
I'll put the video on. And all right. Wow. Okay. So it's always great to have the input from Armen. Set things straight in the plasma world. In our worlds, at least, brings the plasma perspective, which we need to be reminded of. That's why we're here, to remind each other, I think.
Yes, now he just told me how to connect my coils I have been lying around for months not knowing what to do with them. But now I have an idea. Thank you
Good.
so much.
That's great. Yeah, that's exactly what we're here for, is to inspire people to do something with what they have, and thinking outside the box and inside the sphere. Maybe that's the way to look at it.
We'll be flying 4 weeks out.
Yeah, maybe. Sometimes when I work with this material, I try to visualize myself as being in that center of the sphere. What would it be like in the very center of a spinning sphere? What is the position there? We were talking about a merry-go-round earlier, right? Like a ride that you're on, and it's rotating, and the people on the outside part of the ride, of the merry-go-round, they're feeling extreme forces. They can barely hang on and barely pull themselves in. And somebody sitting in the very middle just sits there, and they're slowly going around, and it's like they don't even have to hang on, actually. If they're in the very center, they can just sit there and watch everybody struggling to try to hang on to the forces that are involved in a rotating merry-go-round. So I try to visualize what it'd be like to be a particle in the center, and to You know, how would that not a particle exactly, more of a field, more of a well, let's call it a plasma. If you were a plasma in the center, what would you do? How would you react? How would you get formed and get created, and how would it be expanded and so on? So anyway, yes, it is getting late and I'm getting erratic. Gonna have to shut down here right away if we can. But
oh, it was fun though. It was fun and inspiring, like you said.
Yeah, it was a good ride here. Is there anybody else who I've ignored and wanted to present something? They've been too shy and waiting to the end, and here I am shutting the door on them and so on. But if there is something that somebody'd like to present, and it's you know, willing to go there if someone would like to. We're at 4 hours and 20 minutes or something here, so I like to usually keep it under 4 hours, but it seems to be difficult. Things just keep on trucking. We could probably be here 24 hours a day if so desired, so chose.
Now we have some testing to do.
Yes, that's probably better to do some actual hands-on after a bit of inspiration, a pep talk, and some food for thought here.
Actually, I had a whole bag that I kept from some time ago. Actually, I didn't get rid of it, but they were all coils that I did the wrong side. So now I found a use for it. I'm gonna start doing some different concept, like Armen was suggesting to us.
Yeah, that's interesting. I often do things the wrong way, and sometimes
don't ever throw away stuff that even though there's something wrong. Yeah, keep it aside. You never know what can happen. You know.
Yeah, often, for example, in automotive diagnostics and so on, you try this, you try that, and you're just not getting anywhere with it. And you say, what's going on? Okay, let's just do the opposite then. Instead of what the book says, do the opposite, see what happens. And you hook these connections up different or whatever, and sure enough, you get the result that you were expecting that was supposed to be done the other way, and so on. So I think that, yeah, it's time to let's mix up the connections a little bit, think differently, and
have fun, like Mark said.
Have fun, that's right, what Mark said, that's so important. And you touched on that earlier, that we wanted to get back to some of our early day stuff, and
where we're inspired, was so
sort of having more fun with you know, big discoveries and that kind of thing, and yeah, that's the way to do it, definitely. Having fun, whatever that means. Alrighty, well, let's.
Thank you.
Hey, it's cool. It was fun. I mean, we're all here for the same thing, I guess. We're all climbing the mountain of knowledge, and if we cannot have fun doing it, I mean, sometimes I got to admit, for me, it's quite a struggle. It's a big mountain. Never been, you know, too good with science, so I've been doing it for years, and I see quite a change in myself, and I see somehow my life is getting transformed, and my understanding, and I'm connecting with things. It's very insidious, but I'm growing, and almost every day I remind myself how lucky I am and how beautiful the universe is. Actually, it's a whole process I'm living these days that makes me go through. It's in out. I guess in I receive and I, you know, I get and I receive, and it's basically I'm growing, and there's anyway, there's great things I hope we'll achieve with this. This is my best hope, anyway.
Right on,
Yeah,
Guy.
it's so good to touch base with you guys. You know, every week is always different. It's great to see Guy here. Rick's talked about you quite often. It's great to see your face. And, you know, I love this group. Everyone here, every week's different. You never know what's going to come up, you know, and we get blessed with Armen's words, you know, when he comes in. It's just brilliant. And thank you so much for being here for us.
Thank you, Tony.
Part of it.
Absolute pleasure.
Right on. Libby says it's nice to see Guy again too. Yep. All right. Thanks to everybody. Thanks to everybody for participating and showing up here. And yeah, it's fun, and that's the main thing. We have to keep making it fun. Otherwise, why bother? And if we can impart some of that fun into the fun of transforming this planet into a more tolerable and fun place for everyone, hey, so much the better. I think we can do that through this technology. I know we can. So
Who's gonna have the first fun flying platform?
I mean, who else puts together reactors with toy trucks? Yeah, right. Blow them up because of
That's new ways of using toys.
Jump starting them with too much voltage.
Get pictures, you know, we want to, you know, see someone crash through the side of their wall, you know.
Well, speaking of which, I wanted to prepare for today the exploding Gans ball trick, but with the acrylic balls in a protective cage to take one up to RPMs and see when it actually explodes, a ping pong size ball. So I'll reserve that for next week's episode. Let's put it that way. I'm going to have a 50,000 RPM motor, and there's no way that ball's going to withstand anything more than probably 20, but we'll see. Anyway, I would like to try both the acrylic ball, the ping pong ball, these new plastic balls. Here's that little one that screws into there, that little one I had. I don't know, it's here somewhere. Yeah, anyway, more about this one here, which is a really nice little unit. And it's that kind of squishy plastic, but it's actually quite hard too. Screws into a little doohickey like a light bulb. And if I get a light bulb like this to rotate at, say, 40,000 RPM, that could be very interesting, especially if with that sonoluminescent ball in the middle, it could be a light bulb that glows at that RPM, at its resonant frequency, which would be about that RPM.
Yeah, put the right mix in there and we'll all be flying the ship with peace.
Right on. Okay, let's wrap things up for today. It's been interesting. Thanks to everybody for their wild and wonderful contributions. Some of these contraptions and these things, I don't know, they will probably look on it years ahead and go, whoa, these guys were so backwards in a way, but so ahead of their time in another way. So, because all the funky material stuff that we use, but at the same time we have the knowledge of these fields that is leading edge basically in the world right now, I think. Okay, thanks everybody, and I'm going to end the live stream.
All right, everyone. Oops. Bye-bye.
Bye. Thank you all.
All right. Bye-bye. Okay.